Hello there, and welcome back to The Sleepy Scientist. It is lovely to have you here, settling in for a quiet moment at the end of your day. Tonight we're taking a slow, calming journey through the many moons of our solar system, drifting gently from one world to the next as you unwind. Before we get started, I would love to know where you are listening from this evening, whether it is a cozy room, a soft bed, or somewhere completely unexpected. If you are enjoying these relaxing explorations, please consider leaving a like and subscribing. It truly helps this peaceful little channel reach more nighttime wanderers. And for those of you who are already subscribed, thank you so much for coming back. If you would like to stay gently up to date with future videos, feel free to tap the notification bell so the next upload arrives without you having to look for it. Hopefully this video helps you drift towards sleep without being quite so interesting that it keeps you wide awake. Though if it does, at least the universe might teach you something soothing as you listen. So as you get comfortable, here is something to wonder about. How many moons might be drifting out there right now, circling quietly in the dark, each one carrying its own story? The solar system is wide and calm when seen from afar, but within its stillness lies an extraordinary variety of worlds. Some planets are accompanied by a single faithful moon, while others are surrounded by entire swarms of drifting companions. These moons shape tides, sculpt surfaces, stir hidden oceans, and carry traces of the ancient past. Some glow with ice, some crackle with volcanic fire, and some float through the darkness as quiet fragments of forgotten worlds. This video will guide you slowly from the moonlit comfort of home to the distant frontier, where the smallest, icy bodies circle in the cold. Each step will be gentle, each world visited at an unhurried pace, giving you the space to unwind as you listen. So settle in, breathe softly, and let the journey begin. The moon has been part of Earth's story for as long as the planet has existed in anything like its modern form. It has watched continents drift, oceans form, and climates shift through immense stretches of time. From the moment it emerged out of the debris of a colossal impact in Earth's early history, the moon settled into a role that would become quietly essential. Without it, Earth would move through space in a far less predictable way, tilting and wobbling under the influence of the Sun and the other planets. Instead, the moon's steady gravitational hold keeps Earth's axis anchored, preventing the planet from tipping too far in any direction. That simple stabilizing effect has helped preserve a climate that changes gradually rather than violently, allowing life to develop, adapt, and spread across the surface in ways that might never have been possible otherwise. This stabilizing presence is not something you feel directly when you look at the moon, but it is woven deeply into the behavior of the planet. Earth leans at a gentle angle as it rotates, creating the familiar rhythm of seasons. Without the moon, that angle would wander unpredictably over long spans of time. Some periods would bring extreme tilts that turn seasons into harsh swings between blistering heat and deep cold. Other periods might flatten the tilt almost entirely, leaving regions trapped in long stretches of nearly uniform weather. The moon softens these variations, steadying Earth's motion just enough that environments can remain relatively stable. It keeps the planet behaving in a way that life can reliably adapt to, offering a calm backdrop against which evolution can unfold. The moon's influence is most visible in the tides, which rise and fall in a gentle but persistent rhythm across Earth's coastlines. As the moon circles the planet, its gravity pulls on the oceans, lifting the water slightly and creating bulges that move as the Earth turns. This steady pull shapes the entire boundary between land and sea, washing over beaches, filling estuaries, and tugging at currents along the continental shelves. Over millions of years, tides have sculpted coastlines, carved out bays, and created the tidal flats and marshlands that serve as nurseries for a wide range of life. Early organisms likely benefited from these shifting environments, slipping between shallow pools and deeper waters as the tides advanced and retreated. That gentle rise and fall may even have helped some of the earliest forms of life take tentative steps toward the land. Even now, tides influence ecosystems in ways that might feel subtle, but are deeply important. Many species rely on the rhythm to guide feeding, reproduction, or migration. Fish gather in tidal channels, birds feed on exposed mud flats, and certain coastal plants have adapted to a world where their roots are regularly submerged. The moon does not just illuminate the night sky, it quietly directs the movement of water over most of Earth's surface, shaping habitats that stretch across thousands of kilometers. If the moon were suddenly gone, tides would still exist because of the sun, but they would be far weaker, and many of the coastal systems we know today would slowly fade into something very different. The moon also drifts away from Earth a little each year, moving outward by a small but measurable distance. This slow separation, caused by the same tidal forces that shape Earth's coasts, has been happening for billions of years. In the distant past, the moon was much closer, appearing larger in the sky and pulling more strongly on Earth's oceans. As a result, Earth's rotation has gradually slowed. Long ago, a day on Earth passed much more quickly than the 24-hour cycle we experience now. As the moon continues its slow retreat, days will keep lengthening over vast stretches of time. This connection between the moon's distance and the length of Earth's day is one more example of how both bodies influence each other in ways that often go unnoticed, but remain deeply connected. Looking at the moon through a telescope or even with the unaided eye reveals a landscape frozen in time. Its face is marked with contrasting regions, broad volcanic plains that appear dark and smooth, and bright highlands that stand out with rugged, cratered surfaces. The plains, known as Maria, formed when ancient impacts cracked the moon's crust and allowed lava to flow across the surface, spreading into wide, level basins. These dark patches give the moon much of its recognizable pattern, the shapes that different cultures have interpreted as faces, animals, or symbols. In contrast, the highlands are older and more heavily cratered, bearing the marks of impacts that reach back to the earliest eras of the solar system. Their bright appearance comes from the reflective nature of the rocks and dust that make up this ancient crust. Everywhere on the moon, a layer of fine dust covers the ground. This dust, called regolith, has been shaped through countless cycles of heating and cooling, breaking rocks into powder without the help of wind or water. Sunlight plays across this surface in sharp contrasts because there is no atmosphere to soften the light. Shadows are deep and black, and the illuminated areas are stark and bright. The landscape appears unchanging from one moment to the next, yet it tells a story stretching back nearly the full age of the solar system. Peaks cast long shadows that glide across craters. Ridges catch the light at dawn and fade to darkness at lunar night. Everything feels still, but everything speaks of a long and turbulent past. Human beings have looked to the moon not only as a scientific object, but as a source of meaning. It has been a guide for calendars, a marker of seasons, and a companion to travellers navigating under the night sky. Many cultures developed stories about the moon's markings, interpreting its face in symbolic ways. Some saw deities, others saw animals, and some simply saw a dependable presence that returned every month without fail. The moon cycle from thin crescent to full disk and back again has been a rhythm that people have followed for ritual, agriculture and storytelling. Even today, its phases carry a quiet sense of familiarity, a reminder of time passing in a steady pattern. In more recent history, the moon became the destination for one of humanity's most remarkable achievements. When astronauts stepped onto its surface, they found a world that was both alien and eerily familiar. The grey soil held footprints that remained sharp and undisturbed because nothing on the moon could erase them. The horizon appeared closer due to the moon's smaller size, and the sky above was a deep, unchanging black even in full sunlight. Looking back at Earth from that distance revealed a world suspended in darkness, bright and colourful, floating alone. The moon provided not just a destination but a vantage point that changed how people understood their own planet. Despite how much has been learned, the moon retains an air of quiet mystery. It is close enough to observe in detail, but distant enough that its surface remains untouched, except for a few brief visits. It carries the history of ancient impacts, volcanic floods, and slow erosion caused only by sunlight and micrometeorites. It feels like a neighbour that has been present for every chapter of Earth's story yet remains separate, watching from afar. As the moon hangs in the sky, familiar and constant, it is easy to forget how unusual Earth is in having such a large companion. Not every planet is accompanied by a moon that stabilizes its tilt or shapes its tides. Some worlds move through space without any such partner at all, leaving their climates and rotations to shift under the influence of other forces. The story of the moon is deeply connected to Earth, but it also sets the stage for understanding how other planets move through their long journeys, each shaped by whatever companions they have or lack entirely. Mercury moves around the Sun with a speed that no other planet can match, circling through its orbit in a tight, scorching loop. It is a small world caught in the heart of the Sun's gravitational domain, and that closeness comes with consequences. The Sun pulls on Mercury with such overwhelming strength that the planet has no hope of holding onto a moon. Any object that tried to orbit Mercury would soon be tugged away, either drawn into the Sun or pushed into a path that leads it drifting out into space. Mercury is therefore destined to travel alone, a solitary planet without a companion to share its journey. This solitude shapes the character of Mercury's skies. Standing on its surface in imagination, the horizon feels stark and empty. There are no familiar lunar cycles, no steady returns of a glowing disk rising and setting each night. The sky is dominated instead by the Sun, far larger and more intense than it appears from Earth. During the long Mercury day, the Sun looms so brightly that shadows appear razor-sharp and the ground bakes under the heat. At night, when the planet rotates into darkness, those same landscapes plunge into bitter cold. With no moon to brighten the terrain, the world becomes a field of deep, rigid shadows. Craters and cliffs vanish into blackness, and the sky overhead turns to pure stillness, unbroken by any orbiting presence. Even if Mercury could somehow momentarily capture a moon, the Sun would quickly disrupt the orbit. Its gravity exerts a force on Mercury that is far stronger than the balance between Earth and its moon. Mercury's proximity creates a tug that never relaxes, leaving no stable region where a small satellite could linger. The result is an environment locked into solar influence, where the rhythms of tides, stabilizing tilts, or moon-driven cycles simply never developed. Mercury spins slowly, rotates unpredictably over long spans and has no steadying partner to keep it aligned. Its lonely state is not just a quirk, it is a direct imprint of its place in the solar system. Moving outward from Mercury brings us to Venus, a planet that could hardly feel more different yet shares one crucial detail. It too is moonless. Venus is larger, shrouded in thick clouds, and wrapped in an atmosphere that transforms sunlight into intense heat. Yet despite its size and gravitational strength, Venus also travels alone. This absence has long puzzled scientists, because Venus orbits far enough from the Sun that a moon could theoretically survive. What happened to leave it without one? One theory suggests that Venus may have once possessed a moon, born from a collision similar to the one that created Earth's. In the early solar system, impacts between forming planets and wandering bodies were common. If Venus experienced such a collision, debris might have gathered into a moon that orbited the planet for a time. But Venus rotates in a direction opposite to most planets, and this unusual retrograde spin hints at a dramatic past. A secondary impact could have reversed its rotation, or altered it so significantly that the gravitational interactions between Venus and its moon became unstable. Over time, the moon may have spiraled inward until Venus's gravity tore it apart or pulled it down to the surface. If that happened, Venus once had a companion and then lost it entirely, leaving no trace except in theories and spin patterns. Standing on Venus's surface in imagination is difficult because of the thick, stormy atmosphere, but if one could look up through the clouds, the sky would hold no moon, no illuminated disk to break the monotony. The dense air filters sunlight into an orange glow that never fully brightens or dims in the way Earth's atmosphere does. There is no moonrise or moonset to mark time. Instead, Venus's days and nights stretch in slow, oppressive cycles, dictated solely by its sluggish rotation and thick cloud layers. Without a moon to tug on its oceans, if it had any, or steady its tilt, Venus's climate evolved dramatically differently from Earth's. Its temperature soared as greenhouse gases accumulated, trapping heat until the surface grew hot enough to melt lead. The absence of a moon did not cause this outcome on its own, but it removed one potential stabilizing factor that might have moderated the planet's behavior. The lack of moons on both Mercury and Venus highlights something important. Moons can shape the identity of a planet. Without a companion orbiting nearby, a world must respond entirely to the forces of the Sun, the pull of neighbouring planets, and the interactions within its own interior. On Mercury, this means extreme temperature contrasts, an unstable rotation locked by solar influence, and a surface shaped only by impacts and sunlight. On Venus, the absence of a moon leaves the planet without the tidal forces or stabilizing tilt that may help maintain a balanced climate. Each world becomes an example of how different a planet's evolution can be when it travels alone. Another subtle effect of being moonless lies in the way a planet spins. Without a moon's gravitational influence, a planet's axis can shift more dramatically over long periods. This tilt determines how seasons unfold, how temperatures vary, and how climates change across thousands of years. Earth's tilt remains relatively steady because of the moon. Without it, the axis could wander in ways that would reshape climates repeatedly. Mercury, without a moon, is subject to shifts governed only by its internal structure and the Sun's powerful pull. Venus rotates slowly in the wrong direction entirely, a sign of past upheaval that may have erased any early stability. Moons may not be required for a world to function, but where they exist, they often play a quiet role in keeping the planet's behavior predictable. Life on Earth has grown accustomed to a world with a large moon, but Mercury and Venus reveal what the inner solar system looks like without one. Their skies follow their own cycles, their rotations behave in their own peculiar rhythms, and their climates respond only to the forces acting directly upon them. They drift through space without the comforting presence of an orbiting companion, their nights unlit, and their motions unguided by any steady gravitational partner. As we move outward from these two solitary planets, the solar system changes character. Beyond Earth and Mars, the realms of the giant planets begin, and with them comes a richness of moons that stands in stark contrast to the quiet skies of Mercury and Venus. Instead of loneliness, these regions are filled with companions of every size, from tiny captured fragments to fully developed worlds with oceans, atmospheres, and ongoing geological activity. The transition from moonless worlds to worlds overflowing with moons marks a shift from isolation to abundance, revealing just how varied and surprising the solar system becomes as distance from the Sun increases. Jupiter dominates its corner of the solar system with such immense presence that even from a distance, its influence is unmistakable. The planet's atmosphere churns with storms larger than Earth. Its magnetic field spans millions of kilometers, and its gravity reaches outward to guide an enormous family of moons. Among this vast collection, 4 stand apart. Io, Europa, Ganymede, and Callisto form a group so distinctive that they were once called the 4 great lights of Jupiter, each one carrying the weight and character of a world in its own right. Seen together, they orbit the giant planet in a rhythm that feels steady, ancient, and deeply interconnected. These 4 moons move around Jupiter not as independent wanderers, but as participants in a shared pattern. Their orbits are locked in what is known as a resonance, where the timing of their revolutions aligns in repeating intervals. Europa completes 2 orbits in the same time that Ganymede completes 1, and Io completes 2 orbits in the time it takes Europa to complete 1. This coordinated motion means each moon regularly pulls on the others, creating subtle but persistent gravitational tugs. These tugs stretch and squeeze their interiors, stirring heat and shaping their landscapes in ways that would never occur if they orbited alone. It is as though Jupiter's gravity acts as the central beat, and each moon adds its own rhythm, forming a slow, harmonious dance that has persisted for billions of years. Io is the innermost of the 4, rushing around Jupiter in a tight orbit that places it closest to the planet's immense gravitational power. This position subjects Io to constant flexing. As it travels around Jupiter, the gravity of Europa and Ganymede alternately strengthens and weakens the pull Io feels. This repeated stretching generates intense internal heat, creating the most volcanically active world in the entire solar system. If you were to observe Io from a safe distance, you would see a landscape in perpetual renewal. Vast lava lakes glow beneath the surface, and plumes of volcanic material erupt hundreds of kilometers into space. The colors across its surface range from deep reds to bright yellows, shaped by sulfur compounds heated and spread by relentless volcanic activity. Io lives in a state of continuous transformation, reshaped by forces that never rest. Moving outward from Io brings us to Europa, a moon that could not feel more different. Instead of fiery plains and erupting volcanoes, Europa is wrapped in a shell of ice that hides a deep global ocean beneath. Its surface is one of the smoothest in the solar system, marked not by large craters or mountains, but by long curving cracks that stretch for thousands of kilometers. These lines form where the icy crust shifts and fractures, pulled gently by Jupiter's gravity and by the push of warmer material rising from below. Europa's ice reflects light in a pale, almost luminous way, giving the moon a quiet, frozen beauty. Yet beneath that peaceful exterior lies an ocean kept warm by the same tidal forces that heat Io. While the surface appears still, the world beneath is anything but static, stirred by heat rising through the ocean's depths. Ganymede orbits even farther out, and it holds a distinction no other moon can claim. It is the largest moon in the solar system. In fact, it is even bigger than the planet Mercury. Ganymede carries its size with a kind of calm confidence, displaying a surface that mixes old and new in a patchwork of terrains. Bright, grooved regions stretch across older, darker fields, revealing a long history of geological events. What makes Ganymede especially intriguing is that it has its own magnetic field, something no other moon possesses. This magnetic field interacts with Jupiter's massive magnetosphere, creating shimmering auroras that drift across Ganymede's thin atmosphere. Its internal structure is layered, with rock at the core, ice above it, and possibly multiple ocean layers sandwiched between the ice sheets. Ganymede is a world with depth and complexity, shaped by slow forces working over immense spans of time. Callisto sits farthest out among the four, and its character is different again. If Io is fire and Europa is ice, and Ganymede is a giant shaped by internal motion, Callisto is an ancient, quiet world that has remained largely unchanged for billions of years. Its surface is covered in craters from countless impacts, some of them forming vast circular patterns that stretch across great distances. Unlike Ganymede or Europa, Callisto shows little evidence of internal activity. This lack of geological change means that the marks of past collisions have remained clearly preserved, turning the entire moon into a record of the early solar system. From orbit, Callisto looks like a frozen dark world, sprinkled with bright spots where impacts exposed fresher material. There is a calmness to its appearance, as though it has settled comfortably into a long, unhurried existence at the edge of Jupiter's dominant gravitational reach. When viewed as a group, the four moons reveal a remarkable range of environments. Io's volcanic activity, Europa's icy shell, Ganymede's immense size and internal layering, and Callisto's ancient surface provide four completely different examples of how moons can evolve when shaped by the same planetary giant. Each one responds differently to Jupiter's gravity. Io bends until it becomes molten. Europa flexes enough to warm a deep ocean. Ganymede moves with just enough pressure to shape its crust and maintain a magnetic field. Callisto sits far enough away that the pull becomes gentle, allowing it to remain largely unchanged. Together they show the broad impact a single planet can have, sculpting worlds through heat, motion, and time. Jupiter itself plays the role of conductor throughout all of this. Its gravity keeps the moons in their resonant orbits, ensuring that the tugs between Io, Europa and Ganymede follow a strict pattern. Without Jupiter's immense mass, the entire configuration would unravel. The moons would drift into different paths, their heating would change, and their landscapes would evolve in entirely different ways. Instead, the system functions as a single, unified structure. Each moon reacts to the others, each one influencing the next, and Jupiter governs the entire motion. The result is a collection of worlds that feel connected, not simply because they orbit the same planet, but because their fates are woven together through shared gravitational rhythms. In imagining these moons moving around Jupiter, the sense of a cosmic dance becomes clear. Io rushes ahead. Europa glides in its steady path. Ganymede's orbit traces a wider curve, and Callisto moves in a slow, outer loop. Their motions repeat in cycles that have remained stable long enough to shape their internal structures and surface features. They do not collide or diverge, but follow their silent paths like steps in a pattern laid out across billions of years. Watching them over time would reveal a system with structure, balance and elegance, even as each moon expresses its own unique nature. As this quartet circles Jupiter, their differences create a sense of unfolding complexity. Io's fire, Europa's ice, Ganymede's breadth, and Callisto's ancient scars each introduce a new way of understanding how moons can behave under the influence of a giant planet. The closer one looks, the more distinct their personalities become. Each moon invites its own study, its own moment of attention, and its own understanding of what makes it stand apart. And as these contrasts settle in the mind, the desire naturally grows to turn from the group as a whole to the individual worlds themselves, each offering a separate story shaped by the same central force. Io circles Jupiter in a place where gravity never loosens its grip. Every moment of its orbit brings a fresh stretch or twist, as though the moon is caught between the steady pull of Jupiter and the shifting influence of its neighbouring worlds. Europa tugs from one direction, Ganymede from another, and Jupiter's immense gravity anchors everything in place. Io moves through this web of forces on a tight, fast path. Each time it swings closer to Jupiter, the planet's pull strengthens. Each time it moves away, the pull weakens. The cycle repeats without pause, bending and squeezing the moon over and over again. This relentless shifting of shape is subtle on the surface, but deep within the moon it stirs tremendous heat. Inside Io, this heating becomes impossible to ignore. Rock does not remain solid under such constant pressure. Instead, the interior softens, melts, and rises toward the surface, building chambers of molten material that press upward with enormous force. As the moon continues to twist, these chambers crack open, releasing fountains of lava that burst into the vacuum of space. The entire world is reshaped from within. No other moon in the solar system experiences anything comparable. Io's landscape does not settle. It does not rest. It constantly shifts between eruption and renewal, driven by the perpetual tug of gravity acting like a cosmic pump feeding its fires. Across the surface, the results are unmistakable. Vast lava lakes dominate the landscape, their molten surfaces glowing with deep oranges and reds. These lakes can be larger than entire countries on Earth, shimmering against the surrounding plains. Thick flows of lava roll outward, cooling into dark crusts that fracture and reform as new surges arrive. Towering volcanic plumes rise hundreds of kilometers above the surface, carrying fine grains of sulfur and dust that drift outward before settling again. These plumes arc gracefully in the absence of wind, forming long, delicate shapes that trace the path of each eruption. Even from a distance, the movement of heat through Io is clear. Colours shift in broad, vibrant patches, changing as eruptions cycle through different compositions of molten rock. What makes Io even more remarkable is the silence that surrounds all this activity. On Earth, a volcanic eruption announces itself with thunderous force. Explosions echo across mountains and the ground trembles underfoot. Io has none of these cues. The moon has almost no atmosphere, just a faint whisper of gas that cannot carry sound. Eruptions unfold in complete quiet. Lava breaks through the crust without a sound. Plumes rise into space without a roar. material falls back in utter stillness. A moon experiencing continual global upheaval presents itself as tranquil to the ear, a place where violent forces express themselves only in motion and colour. It is a world where one of the most extreme expressions of geological power feels strangely peaceful simply because there is no sound to accompany it. Yet for all its brightness and activity, Io is not chaotic. Patterns emerge across its surface as eruptions repeat in familiar locations. Some volcanoes erupt regularly, sending rhythmic pulses of material skyward. Others remain dormant for long stretches before suddenly awakening again. The shifts in colour across the plains reflect the chemistry of each event. Some eruptions scatter pale yellow sulphur that settles like frost. Others spread darker, richer tones created by different volcanic mixtures. Over time, entire regions can change their appearance as repeated eruptions build up new layers or remove old ones. Io's surface becomes a gallery of textures shaped by cycles of destruction and renewal, each cycle caused by the invisible hands of gravitational forces acting from afar. If you were to hover safely above Io, the moon would appear alive in a way no other world quite achieves. You would see molten lakes flickering like lanterns scattered across a dark plain. You would watch sheets of glowing material spill outward and freeze into intricate shapes. Plumes would lift and expand until they looked like frozen fountains suspended against the blackness of space. Every movement would be slow, deliberate, and oddly graceful, as though the moon were engaged in a continuous silent performance shaped by a rhythm only it could feel. Even the shadows moving across the surface would shift gently, stretching over ridges and volcanic cones as eruptions gradually reshaped the land. Much of Io's drama comes from its position in the gravitational balance between Jupiter and the other large moons. Europa pulls Io in its direction at predictable intervals, and Ganymede adds a deeper, slower tug. These recurring pulls prevent Io from ever settling into a stable orbit. Instead, it remains slightly off balance, locked into a pattern that ensures continuous flexing. If Io orbited alone, without neighbours to disturb its path, the heating inside would diminish. The eruptions would slow, the landscape would cool and harden. But the presence of Europa and Ganymede guarantees that Io remains caught in a cycle of bending and releasing, a cosmic tension that fuels its fiery personality. Despite its violent nature, Io contributes quietly to the larger Jovian system. Material from its eruptions escapes into space, forming a thin ring of particles that circles Jupiter. Some particles become trapped in Jupiter's magnetic field, creating streams of charged material that interact with the planet's poles and contribute to its powerful auroras. In this way, the moon's volcanic activity does more than reshape Io itself. It sends pieces of its surface outward, becoming part of Jupiter's extended environment. Even in its isolation, Io participates in the broader rhythm of the system, connecting its inner fires to the glowing storms of its giant parent planet. There is something compelling about the contrast between Io's external stillness and its internal turmoil. On the outside, the moon has no wind, no moving air, no sound to mark the intensity of its eruptions. On the inside, vast amounts of heat push relentlessly outward, breaking through again and again. This duality creates the impression of a world that holds enormous tension within, yet expresses it with striking calmness. It is a reminder that silence does not always mean peace, and that the most active places can appear unmoving from afar. As Io continues its orbit, Its fiery display becomes part of a larger story unfolding around Jupiter. The moon closest to the planet burns with constant energy, while the next moon outward presents a stark contrast. Europa, with its smooth ice and hidden ocean, represents an entirely different response to the same gravitational forces. Where Io bends until it melts, Europa flexes just enough to warm a global ocean beneath its frozen crust. The shift from a world of fire to a world of ice is dramatic, and as Io slips into the distance, attention naturally turns to Europa's colder, quieter landscape, waiting farther along Jupiter's orbit. Europa drifts in the cold space around Jupiter with a surface that looks deceptively simple from afar. At first glance it resembles a smooth, pale sphere, almost like a world carved from polished ice. But when you draw closer, the illusion of smoothness fades. Long streaks stretch across the entire moon, twisting and weaving in intricate patterns. These lines resemble cracks, but they are more than simple fractures. They trace the slow shifting of an icy shell that never quite settles. Plates of frozen crust press, pull, and slide past one another over time, leaving behind a rich network of reddish and brownish markings that run for hundreds of kilometers. Some lines fork like delicate branches, while others cut across the surface in nearly straight paths. Each one is evidence of motion beneath the crust. The ice itself is bright and reflective, catching sunlight and sending it back into space with a soft glow. Even in the dim illumination so far from the sun, the surface has a quiet brilliance. The lines spreading across it give Europa a sense of depth, as though the moon wears a map of its own internal movements. These shifting plates move slowly, far slower than anything seen on Earth, yet the effect builds over long spans of time, reshaping the crust bit by bit. The result is a world marked by both stillness and subtle change, its patterns frozen in place yet telling a story that continues beneath the surface. Beneath that crust lies one of the most striking features in the entire solar system. Europa is believed to hold a global ocean beneath its surface ice, stretching around the entire moon. This ocean may be many kilometers deep, far deeper than any body of water on Earth. Although the surface is frozen solid, warmth from below prevents the ocean from freezing entirely. That warmth does not come from sunlight or seasons. It comes from the same gravitational rhythm that affects Io, though far more gently. As Europa orbits Jupiter, the moon is flexed and relaxed in a repeating cycle. This subtle bending releases heat deep within the moon, enough to maintain a layer of liquid water beneath the shell. This combination of cold and warmth creates one of the most tranquil hidden environments imaginable. Picture an immense ocean sealed beneath several kilometers of shining ice. The surface above remains silent and still, yet below it, water extends in every direction, held in darkness and gentle pressure. The ice above acts like a shield, protecting the sea from the harsh vacuum of space. It traps warmth, allowing the deep waters to flow quietly through the moon's interior. There is no noise, no wind, no waves breaking on a shore. Only slow currents moving through a vast shadowed body of water. Even though it is completely sealed away, the presence of this ocean gives Europa a feeling of quiet depth that few other worlds possess. The idea of a hidden sea also helps explain the motion of the crust. When parts of the icy shell warm or cool slightly, they can shift against each other, creating fractures or ridges that rise above the surface. Some regions appear to have rotated relative to their surroundings, as though enormous slabs of ice drifted and then locked back into place. These patterns give Europa an appearance that is both orderly and chaotic. Straight lines intersect with curved ones. Smooth plains lie beside rough, broken terrain. All of it hints at a complex interaction between the solid shell and the liquid layer below. For many observers, the presence of such a vast ocean naturally invites curiosity. It is easy to feel drawn to the possibility of what might exist within those deep waters. But this script remains grounded in what is known. Europa's ocean is inferred from careful measurements. The way the moon's surface moves, the way its internal structure affects gravity, and the way it interacts with Jupiter's magnetic field. These clues paint a consistent picture of a warm, global sea beneath the ice, without needing to step beyond established evidence. The details of what lies inside the ocean remain unknown, but the existence of the ocean itself stands on firm scientific ground. Europa's surface provides further signs of ongoing activity. In some areas, new ice appears to have risen from below, spreading across the surface in fresh, bright patches. Other regions show older, darker ice that has been reshaped over time. Ridges and cracks sometimes appear in parallel lines, as though layers of ice were lifted and then allowed to collapse again. These patterns are subtle compared to the dramatic eruptions on Io, yet they suggest a world that remains active in a quieter, slower way. The shifts in the crust happen over long periods, creating landscapes that are gentle in appearance but dynamic in origin. If you imagine standing on Europa's surface, you would see an almost endless field of pale ice stretching to the horizon. The ground beneath your feet would be solid, yet the knowledge that kilometers of ocean lay below would give the scene an unusual sense of depth. The sky above would be dark even during the day, with Jupiter rising in enormous scale if you stood on the side facing the giant planet. The long cracks in the ice would create lines that guide the eye across the landscape, leading toward ridges and smooth plains that break up the horizon in gentle ways. Everything would feel still, yet you would be standing on a shell that is constantly shifting, even if the motion is too slow to sense directly. Thunderstorms could never form here. Winds could not sweep across the plains. The surface remains locked in deep cold, shaped only by the gradual forces that act from within and from the faint sunlight falling from above. The absence of atmosphere allows every detail to stand out sharply. Bright regions gleam, while darker streaks absorb the little light that reaches them. Shadows fall cleanly across ridges stretching long and thin in the distant sun. The simple play of light and darkness becomes one of the main ways Europa reveals its landscape. Despite the stillness, Europa feels connected to the rest of the Jovian system. Its relationship with Io, Ganymede, and Callisto binds it into a shared gravitational rhythm. Europa's orbit plays a role in shaping the heating that occurs within its own interior. In turn, this heating keeps the ocean beneath the ice in motion and maintains the shifting patterns on the surface. Europa is not an isolated world drifting alone. It is part of a larger arrangement that shapes each moon in different ways. Io responds with fire. Europa responds with water and ice. As Europa drifts onward, its pale shell reflects Jupiter's distant light in soft tones. The moon's quiet patterns contrast strongly with the dramatic activity happening on Io, yet both arise from the same unseen forces. This calm, icy world offers a sense of depth and mystery rooted in its structure rather than speculation. Its hidden ocean, its shifting crust, and its luminous surface all contribute to a feeling of quiet complexity. And as Europa gradually slips behind Jupiter or emerges from the planet's shadow, attention begins to settle on the two larger worlds nearby. Ganymede and Callisto wait farther from the planet, each carrying its own history written into layers of ice and ancient scars. The journey naturally moves toward them, ready to explore a pair of moons shaped not only by the forces of the present, but also by the long memory of the early solar system. Ganymede comes into view like a quiet giant, a moon so large that it surpasses even the planet Mercury in width. It carries a presence that feels steady and confident, the kind of world that reveals its size not through loud displays but through its calm, expansive landscapes. When sunlight touches its surface, patches of bright terrain and darker regions create a mottled pattern that hints at a long and varied history. Despite orbiting deep in Jupiter's shadowy realm, Ganymede maintains an identity entirely its own. One of its most striking traits is something invisible to the eye, but deeply meaningful for understanding the moon's character. Ganymede produces its own magnetic field, something no other moon in the solar system can claim. This gentle but distinct magnetic presence wraps around the moon in a way that resembles the shields surrounding Earth and the larger planets. It stands as evidence that this world is not frozen all the way to its core. Something inside still moves. To picture Ganymede's inner structure, it helps to imagine a sphere built in layers, each one telling part of the moon's story. The outermost layer is solid ice, cold and rigid, shaped by billions of years of bombardment and slow uplift. Beneath that crust lies a deeper region of softer, warmer ice that behaves differently over long stretches of time. Farther down still may be a buried ocean, one stacked between layers of ice like the filling of an enormous frozen sandwich. At the moon's centre sits a metallic core that behaves more like the insides of a small planet than a typical moon. The movement of charged material within this core is likely what generates Ganymede's magnetic field. The entire structure feels peaceful and methodical, built from components that work together in silence and steady order. On the surface, this internal structure expresses itself in patterns that appear youthful compared to many icy worlds. Bright, grooved regions stretch for hundreds of kilometers in sweeping arcs and curved lines. These grooves resemble the wrinkles that form when a crust shifts or stretches over time. They cut across darker, older areas of the surface, where impact craters crowd together in dense clusters. These contrasting terrains suggest that Ganymede has experienced periods of relative activity, where forces from within reshaped its upper layers. Perhaps old surfaces cracked open, allowing new ice to rise. Perhaps slow movement deep below changed the patterns of stress in the crust. These processes happened on a scale far beyond any human time frame, yet the traces remain visible and clear. Even with these signs of activity, Ganymede maintains a sense of stillness. Standing on its surface, you would see long ridges rising softly above the plains, their shadows stretching out in the faint Jovian light. Craters large and small would dot the landscape, some crisp and fresh, others eroded by countless years of slow change. The horizon would feel both broad and gentle, shaped by low hills rather than towering mountains. The quiet would be complete. Cold temperatures and near absence of atmosphere mean no wind sweeps across the plains, and no sound travels through the empty air. All movement happens slowly, almost imperceptibly. A short distance farther from Jupiter, Callisto circles the planet with a calmness that borders on absolute stillness. Callisto is nearly as large as Mercury as well, yet it carries a personality entirely different from Ganymede's. Instead of possessing a magnetic field or signs of internal layering, Callisto appears much more uniform beneath its outer crust. Its interior is thought to be a mixture of ice and rock, blended together in a way that never fully separated into defined layers. This simplicity is part of what gives Callisto its unique charm. The Moon did not experience the same internal heating or dynamic rearrangements that shaped Ganymede. Instead, it settled early in the history of the solar system and has remained largely unchanged since. This ancient calm is written across its surface in countless impact craters. Callisto is often described as one of the most heavily cratered worlds ever observed. Every region of its surface is dotted with circles large and small, some overlapping and others standing alone. These craters are not only numerous but incredibly old, dating back to the period when impacts were far more common. The density of these features gives Callisto the appearance of a world suspended in time, holding on to traces of a violent era long ended. Where Ganymede's surface shows a mix of old and young features, Callisto's landscape presents an unbroken record of age. Many of the craters on Callisto have softened edges due to slow processes acting over millions of years. Small amounts of ice may have migrated across the surface or settled in low areas. Countless micrometeorites have arrived silently, gradually wearing down sharp features. Yet the overall pattern remains remarkably preserved. Callisto seems to be a world that chose quiet endurance over renewal. Nothing rises from within to reshape the crust. Nothing stirs beneath the surface to alter the landscape. The Moon exists as a kind of frozen library, storing billions of years of history in each mark and depression. If you were to stand on Callisto's surface, the view would feel noticeably different from that of Ganymede. The ground would be darker, made of ice mixed with dust and rock. The horizon would be dotted with gentle rises formed by the rims of ancient craters. Some of these craters contain central peaks, pushed upward by the force of impacts long ago. Others display rings within rings, where shock waves carved multiple boundaries into the crust. Every direction would hold reminders of an early solar system filled with collisions and chaos. Yet the silence would be complete, and the stillness would give the impression of a world that has been resting for ages. Comparing Ganymede and Callisto reveals two distinct paths taken after their formation. Both moons likely formed around the same time, built from the same mixture of ices and rocky material, and shaped by similar early conditions. Yet subtle differences in their distance from Jupiter, their internal heating, and their orbital motions set them on different trajectories. Ganymede warmed enough to separate into layers and develop a core capable of generating a magnetic field. Callisto cooled early and never experienced the same degree of separation or tidal shaping. These divergent histories created moons that exist side by side yet reflect entirely different versions of how an icy world can evolve. Despite their differences, both moons contribute to the larger story of Jupiter's system. Their presence helps maintain the balance of gravitational forces acting on Jupiter's extended family of moons. Their surfaces preserve clues about the conditions present billions of years ago. Their varied compositions help scientists understand how icy bodies behave over long stretches of time. Each moon offers a quiet chapter in the unfolding story of planetary formation, written in ice, rock, and silence. As the focus moves away from these two giants, the space around Jupiter becomes more crowded. Beyond Ganymede and Callisto lies a wide collection of smaller moons, each one irregular in shape and origin. Some are captured objects from the early solar system. Others may be fragments of larger moons broken apart by ancient impacts. Together, they drift through Jupiter's gravitational field in paths that weave between the giant moons and the planet's vast influence. These small companions form a scattered, intriguing community that invites further exploration as the journey continues deeper into Jupiter's realm. Far beyond the familiar orbits of Io, Europa, Ganymede and Callisto, Jupiter's realm continues to expand into a wide and uneven collection of much smaller moons. These tiny companions, scattered across great distances, rarely draw attention on their own. Many of them are only a few kilometers across, shaped like lumpy stones or stretched fragments rather than neat spheres. Their surfaces are dark, coated in ancient dust and rock that reflect almost no sunlight. Yet together they form a population so large and varied that they give Jupiter one of the richest moon systems in the solar system. Each of these little bodies travels on its own quiet path, drifting through a region where sunlight is faint and Jupiter's gravity dominates every motion. Most of these small moons did not form beside Jupiter in the early days of the solar system. Instead, they were likely captured long ago, pulled into orbit by the giant planet's tremendous gravitational field. Imagine the early solar system as a place filled with loose material where countless rocky bodies wandered freely. Jupiter, with its immense mass, acted like a cosmic net. Anything that passed too close could lose enough energy to become trapped. Some objects entered stable orbits. Others swung around the planet a few times before colliding or being flung away into the darkness. Over billions of years, the result was a community of moons that began life elsewhere but now belonged to Jupiter's vast family. Because these moons came from different regions and moved with different speeds, their paths around Jupiter tend to be irregular. Some of them orbit far out, taking hundreds of days to complete a single loop. Others move closer in, with orbits that tilt at sharp angles relative to the plane in which the four major moons travel. Many of them follow orbits that are not circular, tracing stretched shapes that bring them closer to Jupiter at some points and much farther away at others. These unusual paths help reveal their captured nature. Worlds that form together tend to travel smoothly. Worlds collected over time arrive with the momentum and direction they had before being caught. One of the most striking behaviors among these small moons is the tendency for many of them to orbit Jupiter in reverse. While most moons in the solar system travel around their planets in the same direction their planets rotate, dozens of Jupiter's small companions move the opposite way. The concept can be understood without any specialized knowledge. Picture Jupiter spinning in one direction, its major moons following that same motion like boats moving downstream. Farther out, the tiny irregular moons drift upstream, slowly pushing against the flow. These retrograde moons are reminders that they are not born within Jupiter's original system. They came from elsewhere and kept much of their old momentum even after being captured. Within this group of retrograde moons, there are clusters that share similar paths. These clusters hint at dramatic events in the deep past. When a captured object enters orbit around Jupiter, it is often unstable at first. Collisions are common. A single impact between two small moons can create a cloud of fragments that eventually settle into their own orbits. Over time, these fragments become distinct moons, each with its own shape and path, yet linked by a shared origin. Several such clusters exist around Jupiter, forming quiet families of objects that came from the same parent body. Their orbits group together like gentle echoes of an ancient collision. The sizes of these moons vary, but most of them are tiny. Some are only a few kilometers wide, no larger than a hill. Others stretch tens of kilometers across but remain irregular, shaped by impacts rather than by gravity smoothing their edges. Their surfaces are covered with dark material that makes them difficult to see, even for powerful telescopes. If you could stand on one of these worlds, you would find a landscape without any atmosphere, marked by scattered craters and loose rock. The pull of gravity would be so weak that even a small step could send you floating away if you were not anchored. There would be no sound at all. Only the distant glow of Jupiter hanging in the black sky would break the stillness. Because sunlight is weak this far from the sun, the appearance of these moons is shaped mainly by shadow. Ridges cast long, dark lines across the ground. Small boulders create patches of deep contrast. The slow rotation of each moon means that day and night last a long time, stretching into many hours of quiet dimness before the sun rises or sets. The surroundings feel peaceful yet remote, a place where time seems to slow down, and each crater feels like a relic stored in darkness for an unimaginable length of years. When these moons pass near one another, they rarely interact directly. Their orbits are spread over such great distances that most never come close enough to collide again. Instead, they drift along their individual paths like members of a loosely arranged parade, each keeping a respectful distance from the next. The vast emptiness around them prevents the kind of activity seen on larger moons. There are no eruptions like those on Io, no shifting ice like that on Europa, no grooved surfaces like those on Ganymede. These tiny moons exist in a state of quiet preservation, carrying fragments of ancient worlds that no longer exist. Despite their small size, these moons play a role in shaping Jupiter's extended environment. Their gravitational pulls, though weak, contribute to the slow shifting of orbits among neighbouring moons. Dust created by impacts on their surfaces can drift into space and join other particles orbiting the planet. Some of this material may eventually fall into Jupiter, while other fragments may strike larger moons or join faint ring structures. In this way, these irregular moons act as subtle participants in the ongoing evolution of the Jovian system. Observing them from a distance, you would see Jupiter dominate the sky. Its striped atmosphere would glow softly, and even at these far distances its sheer size will be unmistakable. The small moons around you would appear as tiny points of rock following paths determined by the planet's vast gravitational reach. There is a gentle beauty in their motion, a kind of drifting harmony created by objects so small, yet so faithfully bound to a giant. These moons also offer a glimpse into the early days of the solar system. Their captured nature suggests that Jupiter once moved through regions filled with loose material. As the planet settled into its present orbit, it gathered objects along the way, keeping some and discarding others. Each small moon represents one of these captured travellers. Their presence hints at conditions that no longer exist, but once shaped the structure of the solar system we know today. As these small moons continue their steady journeys through Jupiter's distant reaches, the sense of quiet isolation they create begins to shift. Their dark forms drift through space like scattered reminders of a much earlier era, but the path ahead leads toward a very different kind of celestial neighbourhood. Beyond Jupiter's scattered swarm lies a world where structure replaces randomness and brightness outshines shadow. The next stop brings you into the realm of Saturn, a planet whose moons move with a softness and order that contrasts sharply with the rugged fragments left behind. It is a place where rings trace delicate patterns across the darkness and where each moon seems to fit into a wider design, inviting a slower, more graceful exploration. Saturn appears as a calm and distant giant, a world wrapped in soft light and circled by rings that seem almost too delicate to belong to a planet so large. From afar, those rings look like a single smooth band, but as the view draws closer, countless thin strands become visible, each one made of ice and dust moving together in long, sweeping curves. These rings form an enormous, graceful structure around the planet, but they do not flow freely. Their shape is constantly tended by the moons that travel along their edges, guiding them like quiet caretakers, working in the background of a much larger design. Among these caretakers are the shepherd moons, small worlds that travel beside the rings and gently pull on them with their gravity. As they move, they keep the icy particles confined to certain paths, stopping them from spreading or blurring into one another. Their presence ensures that gaps remain clean, edges stay sharp, and the rings as a whole retain the kind of organisation that makes Saturn instantly recognisable. Without these moons, the rings would slowly lose their crisp structure, drifting into broader and less defined shapes. Instead, the system holds its form with surprising precision, maintained through interactions that happen silently over unimaginable stretches of time. Some shepherd moons are so small that they barely resemble spheres, shaped instead by the same collisions and impacts that sculpted many small bodies in the outer solar system. Others are more regular, with surfaces that carry the marks of ancient activity or old fractures frozen in place. Each one moves along its path with a steady rhythm, working in ways that are almost invisible on short timescales, yet absolutely essential over longer ones. Their influence stretches outward, guiding grain-sized ice crystals, snowy clumps and larger fragments that drift in looping arcs around the planet. Together, these pieces form the ring's shimmering bands, lit gently by sunlight filtered across great distances. Beyond the shepherd moons lie Saturn's other companions, a collection that ranges from tiny fragments only a few kilometers wide to large bodies complex enough to hold layered interiors and distinct landscapes. These moons move in wide, sweeping orbits, some close to the planet, others much farther away where the pull of Saturn begins to soften into the general gravity of the outer solar system. Each moon carries its own slow story carved into its surface. Some display smooth icy plains that hint at buried oceans or long frozen processes beneath the crust. Others are covered in deep craters or fractured terrain, shaped by billions of years of drifting under a gentle but constant rain of impacts. The variety inside Saturn's system creates a sense of calm complexity. Every moon appears to belong exactly where it is, moving with a pace that suits its size and distance. The spaces between these moons are wide, giving them room to drift without interruption, and the rings below them act as a bright, broad stage that reflects sunlight far into the surrounding darkness. There is no rush in the movement of this system. Everything proceeds slowly, each orbit taking days or weeks or longer, forming a pattern that repeats itself while still allowing subtle changes to unfold over enormous periods of time. Even from a great distance, the planet and its moons share a quiet symmetry. The rings cast thin shadows across the cloud tops, and the moons glide through these shadows as they circle the planet. Sometimes they disappear behind the rings, hidden for a short moment before reappearing on the other side. Other times, they pass directly in front of Saturn, creating gentle silhouettes that drift across the pale bands of its atmosphere. The entire scene feels unhurried, as if it exists in a rhythm separate from the rest of the solar system, shaped by the steady pull of gravity and the slow rotation of the planet beneath. Saturn itself moves with a surprising grace. Although it is enormous, its rotation is fast, giving it a slightly flattened appearance, but the effect is subtle enough that it only enhances the sense of roundness and depth. Bands of cloud circle the planet, their colours muted compared to Jupiter's vivid stripes, creating a softer, more blended pattern. Within these clouds, storms swirl and fade, but from afar the planet seems almost perfectly calm. That calmness makes the moon system around it feel even more balanced, as if everything has settled into the arrangement it was always meant to have. In the outer stretches of Saturn's influence, the larger moons appear as worlds in their own right, offering a wide range of surfaces and structures. Some are marked by canyons, ridges, or broken landscapes where ancient activity once reshaped the ground. Others remain heavily cratered, showing little change across billions of years. Even the smallest moons carry clues to the past, their uneven shapes formed by impacts or by fragments colliding and merging. Together they demonstrate the long history of building, breaking and settling that has defined the outer solar system. The stillness of the region also gives space for light to behave differently. Sunlight falling on the icy moons reflects brightly, making them stand out against the darkness. Shadows stretch far across crater rims, and narrow ridges glow faintly along their edges. Where the rings arc overhead, they scatter light so that even the night side of a moon can appear softly illuminated by reflected brightness. This creates an atmosphere of quiet radiance, a gentle glow that adds to the sense of peace and slow movement that defines the whole system. Moving from one moon to the next reveals the subtle range of colours and textures that make Saturn's domain feel surprisingly alive. Some surfaces appear almost pure white, others take on soft greys or pale blues, and a few display warmer tones where certain minerals or organic compounds have settled. These changes in colour are small, but they add depth, giving each moon its own look even when the differences must be observed closely. Each detail becomes another thread in the tapestry of a system that feels both delicate and immense. All of these features, from the carefully sculpted rings to the quiet moons beyond them, come together to form a place where movement and stillness blend into a single impression. Saturn does not appear chaotic, nor does it feel empty. Instead, it stands as a model of balance, showing how gravity can create structure, order, and beauty simply by drawing objects into motion. Everything turns at just the right pace, pulled into orbits that hold steady as the years pass. From within this gentle architecture, one moon stands out among the rest. Titan waits at a distance where its thick atmosphere and unusual weather systems can unfold far from the bright glare of the rings. The path toward Titan leads into a different kind of world, one where seas form from liquid methane, clouds drift through an orange sky, and the surface hides mysteries beneath layers of haze. Moving from Saturn's ordered serenity toward this larger moon brings the sense of approaching a place that blends familiarity with strangeness, inviting a closer look at a world shaped by cold chemistry and slow cycles. Titan appears as a muted lantern in the darkness, glowing softly beneath a shroud of golden haze. From afar it looks almost gentle, wrapped in a thick atmosphere that scatters sunlight into an amber glow. This dense blanket makes Titan one of the few moons in the solar system with a truly atmospheric presence, and the only one whose air resembles the early conditions of Earth. Yet everything about it is colder, slower, and shaped by chemistry that feels both familiar and strangely distant. The haze that surrounds the moon creates a sense of calm enclosure, softening its edges and giving it an appearance that feels almost dreamlike against the deep black of space. Stepping closer reveals just how rich Titan's skies really are. Sunlight filters through the layers of haze in long, muted beams, falling softly on the surface below. Even in the daytime, the light feels subdued, as though the sun exists behind a curtain of pale gold. The thickness of the air gives Titan a kind of presence that few other moons can match. The sky is not silent, it behaves like a world sky should, carrying the faint whisper of winds and allowing clouds to drift slowly across the horizon. Each element of this atmosphere works together to create a serene and timeless quality, as if everything on Titan unfolds at a patient pace. Within this atmosphere, weather takes shape in forms that mirror Earth, but operate under very different rules. Clouds gather from methane vapor rather than water. They move and disperse, sometimes thickening into storm systems that bring gentle rainfall across the landscape. Methane rain behaves much like a cold, delicate drizzle, falling onto riverbeds and plains that have been carved by flowing liquid over countless seasons. These rains refill lakes and seas made entirely of methane and ethane, which stretch across Titan's surface like dark, still mirrors. Their shapes are sharp and defined, with coastlines that curve through fjord-like inlets and wide basins. Flowing outward from these bodies are networks of rivers, branching and winding through valleys shaped by years of erosion. These channels are evidence of a cycle that repeats continuously, even in the extreme cold. Rain forms, falls, travels across the landscape, gathers into streams, and eventually returns to the larger seas. This rhythm gives Titan an underlying sense of life, not in the biological sense, but in the way the environment breathes and changes through repeating patterns. The entire moon behaves like a frozen Earth analogue, echoing processes that shaped our own world long before oxygen filled the air. Many scientists look at Titan and see a record of ancient Earth, preserved in the cold. The thick atmosphere, the presence of liquid on the surface, and the constant reshaping of terrain all mirror conditions that may have existed on our planet billions of years ago. But Titan is not a warm, humid cradle. Its temperatures keep methane liquid and water locked solid as rock. Lakes ripple with hydrocarbons instead of water. Sand grains form from organic particles that drift slowly out of the atmosphere before being swept into long dunes by steady winds. The strangeness of these features creates a world that feels both familiar and foreign, like a memory viewed through a distorted lens. On the ground, the experience becomes even more unusual. Standing on Titan's surface would feel like being held beneath a thick, dim sky, tinted a warm orange. The light would be gentle, never harsh, casting long shadows even at midday. The air, though far colder than any winter on Earth, would press around you with real weight, thicker than any atmosphere found elsewhere in the outer solar system. The horizon would look slightly blurred, softened by the ever-present haze. Distant hills would fade into the gold, their shapes barely defined at the edges. The world would feel quiet, wrapped under an atmospheric blanket that muffles any sound and gives each movement a slow, steady calm. Large seas lie near Titan's poles, vast expanses of liquid methane and ethane that curve with coastlines just as Earth's oceans do. Along those shores, waves rise only slightly, as the low gravity and thick air make it difficult for strong winds to form. The stillness of these seas creates a sense of deep tranquility. Even the reflective surfaces appear dim, catching faint traces of the filtered sunlight and shimmering in subdued tones. Small islands dot some of these regions, their outlines softened by mist drifting above the cold liquid. In other places on Titan, dunes stretch across the terrain in long dark lines. These dunes form from tiny grains shaped by organic processes rather than ground-up rock. Winds carry them into patterns that run for hundreds of kilometers, shaping the landscape into gently repeating ridges. Moving across these dunes would feel slow and steady, with each ridge rising at a comfortable slope. Their dark colour contrasts with the pale haze above, giving the ground a textured appearance that seems to stretch endlessly. Canyons also carve their way through Titan's crust, some deeper than many earthly valleys. These canyons were cut not by water, but by liquid methane flowing with persistent determination over enormous spans of time. The walls of these channels appear layered, revealing histories of rainfall, erosion, and deposition. The slow changes to these shapes create a surface rich in geological memory, with features that have taken millions of years to settle into their current forms. Everywhere one looks, Titan maintains an atmosphere of quiet persistence. Weather comes and goes, carving its patterns gently rather than violently. The clouds drift in and out of view, sometimes thickening into dense patches that obscure the horizon entirely. Other times they thin until only a faint mist remains. The sky and ground feel connected, bound together by cycles that continue endlessly in the cold. Despite all this activity, Titan never feels hurried. Its climate moves slowly, its surface changes gradually. Every feature unfolds with a patience that suits a world so far from the sun. This slow pace of change adds to the sense of stillness that defines the moon. It feels like a place where time stretches, where everything settles into long flowing rhythms rather than abrupt shifts. Moving away from Titan, the golden haze begins to thin, revealing the blackness beyond. As the atmosphere fades into space, a different kind of moon comes into view. Enceladus waits nearby, bright and icy, with geysers that break through its frozen crust and spray into the darkness. Leaving Titan's soft, hazy world behind opens the way toward a place shaped not by thick air and liquid seas, but by jets of ice rising from a hidden ocean deep below. Enceladus appears at first as a shard of a light against the darkness, a world so reflective that it almost seems to glow from within. Its surface is made of clean, compacted ice that bounces sunlight back with remarkable efficiency. Even from afar, this tiny moon stands out sharply against the deep shadows of Saturn's realm. The brightness gives Enceladus a delicate presence, as though it were carved from frost and gently placed in orbit. Its ice crust hides a very different environment below, one that reveals itself through spectacular signs of motion and energy. Approaching the moon brings the smooth sheen of its icy plains into clearer focus. Large areas are nearly free of craters, telling the quiet story of a surface that renews itself. This smoothness suggests continuous activity far below the crust. Bright fractures stretch for long distances, creating patterns that resemble pale scars across the landscape. These marks are reminders that Enceladus is not a frozen relic, but a dynamic world shaped by subterranean forces. The combination of shimmering plains and stark fissures creates an appearance unlike any other moon in the Saturnian system. Along the southern hemisphere, the signs of internal heat become impossible to ignore. A system of long, parallel fissures runs across the region like deep blue stripes. These features, often called tiger stripes, serve as escape routes for the world beneath, Within them lies the source of Enceladus's most dramatic behaviour. Pressures build deep inside, driving warm water upward until it escapes violently into the vacuum. The contrast between the frozen exterior and the energy pushing through it forms one of the most striking natural contradictions in the outer solar system. The geysers that erupt from these fractures burst with extraordinary power, releasing water vapour and tiny grains of ice in continuous streams. They rise hundreds of kilometres above the surface before drifting outward into space. The spray looks feather-light, illuminated by sunlight and scattering into delicate veils. Against the darkness, the jets appear almost luminescent. Their movement is slow and graceful once they leave the fractures, transforming from forceful eruptions into drifting plumes that fall back toward the surface or escape to join Saturn's larger environment. These eruptions provide clues to what lies beneath the icy crust. Instruments have detected salts mixed into the grains thrown into space, implying that the water originates from a liquid reservoir that interacts with rocky material below. This suggests not only an ocean under the surface, but an ocean with complexity. Alongside the salts, organic compounds have been found, simple building blocks that raise intriguing questions about what processes might unfold in such a hidden sea. The discovery of these materials does not reveal life, but it does show that Enceladus possesses some of the essential ingredients for chemistry of great significance. The falling spray collects on the surface, coating the southern terrain with fresh ice. This repeated process keeps the area bright, renewing the reflective sheen that distinguishes the moon. In some regions, the particles settle softly, creating a frost-like layer that smooths the ground. In others, the grains accumulate along ridges or gather in low areas, shaping subtle patterns. The ongoing cycle of eruption and deposition creates a world that changes continuously through gentle layering rather than violent transformation. As the sprays extend outward, some particles drift far enough into space to encounter Saturn's gravity. A portion of the material becomes trapped within one of the planet's faint rings. The particles are small, light, and bright, giving the ring a delicate, almost ghostly quality. Through this process, Enceladus contributes directly to the structure of Saturn's ring system. The frozen grains released into orbit circle the planet for long periods, creating a soft halo that reflects the moon's influence long after the geysers have erupted. Standing near one of the fissures would present a sight both calming and surreal. Towering jets of vapour would rise endlessly into the sky, illuminated by the distant sunlight. The surface would be quiet beneath your feet, with only the soft settling of ice grains from above. The airless environment would carry no sound, so even the most powerful eruption would unfold in perfect silence. The only movement would be the slow drift of icy particles falling like snow that never melts. Enceladus feels serene despite its activity, a world where great forces express themselves in gentle ways. The contrast between the frozen terrain and the warm ocean hidden below adds another layer of fascination. The ice shell acts as a protective blanket, preserving the sea beneath, while allowing only selected signs of its presence to escape. Heat rising from the interior keeps the water liquid despite the immense cold of space. The interactions between rock, water, and heat create a system that is remarkably complex for such a small moon. Every plume rising from the surface is a direct message from this concealed ocean. Enceladus is not defined solely by its geysers, though they are its most spectacular feature. The rest of the surface displays patterns of ancient fractures, smooth plains, and scattered craters. Some regions appear as though they once shifted or rotated slightly, hinting at tectonic movements beneath the crust. Other areas preserve older features, showing a past marked by impacts and slow erosion from falling ice grains. The mixture of young and old landscapes reveals a world with a long and varied history, shaped by cycles of freezing, heating, and resurfacing. As the Moon moves through its orbit, the geysers pulse with slight variations. These changes align with the gravitational pull of Saturn, which stretches Enceladus just enough to influence the flow of water beneath the surface. This constant rhythm drives the internal processes forward, feeding the ocean's circulation and encouraging the repeated eruptions. The interplay of gravity, heat, and motion forms a balanced system that keeps the Moon alive with activity. Watching the particles scatter into space provides a sense of how connected Enceladus is to its surroundings. Some grains fall back, settling quietly. Others drift outward, becoming part of something larger. Saturn's vast rings catch many of them, weaving them into the intricate patterns that encircle the planet. Through these contributions, Enceladus becomes more than a moon. It becomes a participant in shaping the larger structure of the Saturnian system. Leaving Enceladus behind, the brightness of the Moon fades into the wider view of Saturn's many companions. Not all of these moons are smooth or symmetrical. Some possess unusual shapes, fractured surfaces, or puzzling features that reflect very different histories. Moving onward brings you into a region shaped by collisions, irregular forms, and ancient scars, where Saturn's strangest worlds wait in quiet orbits. Hyperion drifts through Saturn's realm, as though it never fully decided what shape it wanted to take. Instead of the smooth surfaces common to many moons, Hyperion appears carved, hollowed, and worn down by ancient impacts that left behind a landscape so porous it resembles a frozen sponge. Its craters are deep and oddly shaped, their walls crumbling inward, as though the material beneath them barely holds together. Touching its surface would feel like pressing against compressed snow rather than solid rock. The Moon tumbles chaotically as it orbits, never showing the same face twice, giving it a restless, unpredictable presence among Saturn's more orderly companions. The low density of Hyperion offers a clue to its unusual appearance. It is thought to be made of ice mixed with pockets of empty space, a structure that allowed impacts to carve downwards rather than outward. Instead of shattering the Moon or sending debris into space, collisions sank into its soft interior, sculpting caverns and dimples that reach surprising depths. Light falling across its surface casts long shadows inside these cavities, revealing intricate textures that seem almost organic. Hyperion holds on to very little debris because its gravity is so slight. Much of what strikes it escapes into space rather than settling again. As a result, each crater remains open and sharp, untouched by gradual filling. Though Hyperion's appearance may seem chaotic, it tells a steady story of what life is like for small worlds on the outskirts of a giant's domain. They endure impacts that reshape them repeatedly, and without strong gravity to heal their surfaces, the marks remain. Hyperion embodies that vulnerability. It is a reminder that even in the quiet reaches of the outer solar system, time is written most clearly in the scars of collisions that happened long before humans ever looked toward the sky. Farther outward, another moon presents an entirely different face. Iapetus moves in a wide, slow orbit that gives it a detached, reflective quality, as though it keeps a thoughtful distance from Saturn's bustling inner system. Its most striking feature is its sharp two-tone surface. One hemisphere is dark, coated in material that absorbs sunlight and creates an appearance almost like charred wood. The other is bright, covered in clean ice that reflects light with a gentle brilliance. The dividing line between these two sides is surprisingly abrupt, giving Iapetus a split identity that stands out even among the solar system's most unusual moons. This stark colour contrast may be the result of material falling inward from the outer reaches of Saturn's system, gradually tinting the leading side of Iapetus as it orbits. The dark surface warms more easily in sunlight, causing icy material to sublimate and drift away, which further deepens the contrast. Meanwhile, the opposite hemisphere remains bright and cold, preserving its pale coating. The entire moon becomes a study in how small differences, repeated over long spans of time, can sculpt a world into something beautifully asymmetric. Along its equator, Iapetus displayed another curiosity, a long ridge that rises like a wall encircling the moon's waist. Some sections of this ridge climb several kilometers above the surface, shaping a silhouette unlike anything else in Saturn's entourage. The origin of this feature remains a topic of scientific interest, with possibilities ranging from ancient tectonic activity to the remnants of a collapsed ring system that once circled the moon itself. Whatever its source, the ridge adds to the impression that Iapetus is a place where forces once acted strongly, leaving behind a landmark that runs across the surface in an almost geometric band. While Hyperion and Iapetus present dramatic extremes, another moon tells a smaller but equally compelling story. Mimas, modest in size and simple in shape, carries one overwhelming feature: a giant impact basin that dominates its landscape. This basin is so large compared to the moon's diameter that it reshapes the entire world's appearance. A vast central depression sits surrounded by steep walls and radiating fractures. It looks like an imprint left by a blow that nearly broke the moon apart. The impact was forceful enough to send shockwaves through Mimas, forming patterns of cracks on the opposite side of the moon where the energy converged. Despite its violent past, Mimas today drifts quietly around Saturn, worn smooth in places by ancient processes. The large crater gives the moon an appearance that viewers often describe as familiar, though in reality it is a symbol of how catastrophic events shaped the early solar system. The fact that Mimas survived such an impact without shattering speaks to the resilience of icy bodies, even when struck with unimaginable force. Every orbit it completes is a reminder that some worlds bear their greatest scars in plain sight. These moons, each with their own strange shapes and distinctive features, reveal the diversity of Saturn's lesser-known companions. They stand apart from the smooth serenity of Triton or the luminescent activity of Enceladus. Hyperion tells of delicate structure and porous ice shaped by collisions that carve downward rather than outward. Iapetus offers a world defined by contrast, with a darkened side warmed by sunlight and a bright hemisphere locked in cold reflection. Mimas focuses all attention on one colossal impact, a world shaped by a single moment of violent transformation. Together they form a gallery of forms sculpted by ancient events. Unlike the larger, more internally active moons, these smaller bodies do not rewrite themselves through tectonics or resurfacing. They remain honest record keepers, preserving the history of impacts, transformations, and cosmic chance. Their surfaces are stories written in craters, ridges, fractures, and shadows, each shaped by collisions that happened long before humanity imagined exploring distant planets. Moving from one to the next gives the sense of wandering through a museum of celestial relics. Every world displays something unexpected, something that breaks away from the familiar patterns elsewhere in the solar system. Some moons resemble icy sculptures, others appear fractured or half-darkened, and all of them drift through space with a quiet steadiness. They do not boast dramatic geysers or thick atmospheres. Instead, their intrigue lies in their shapes, textures, and the histories carved across their surfaces. As attention lingers on these moons, a broader picture emerges. Saturn's system contains everything from elegant ring shepherds to rugged fragments shaped by countless impacts. It is a world where delicacy and violence sit side by side, where calm orbits hold objects formed in the harshest moments of the solar system's early years. The strange moons reflect this contrast as clearly as any feature in the region, offering glimpses into past eras marked by collisions and reconstruction. When the journey moves beyond these unusual worlds, the character of the outer solar system begins to shift once more. Saturn's environment fades gradually into the background, and a new realm approaches, one defined by a planet with a very different posture. Uranus waits ahead, spinning sideways through space, carrying its own collection of moons that orbit around an axis tilted almost completely on its side. The transition brings with it a subtle change in atmosphere, leading toward a system where everything, seasons, orbits, and light, unfolds in an entirely different way. Uranus moves through the outer solar system in a way that sets it apart from every other major world. Instead of spinning upright like most planets, it rolls through space on its side, tilted so far that its poles point almost directly toward and away from the Sun during portions of its long orbit. This unusual orientation affects everything around it. The sunlight falls across its atmosphere in sweeping, uneven bands, and its moons cycle through seasons that feel stretched, distorted, and unlike anything experienced closer to the Sun. The entire system seems to turn sideways, creating a calm but strange environment where light and shadow behave in unfamiliar ways. The planet itself has a muted blue-green colour, softened by a haze of icy clouds. Beneath that calm exterior lies a giant world, but the stillness of its atmosphere gives it a distant, understated character. Even the rings around Uranus carry this subtle quality. They are thin, dark, and narrow, almost invisible unless the light catches them correctly. The moons move through this tilted plane, orbiting around a world that behaves as though gravity has been rotated 90 degrees. Each moon reflects the planet's unusual posture, following paths that feel slightly out of step with the more familiar orbits seen around Jupiter and Saturn. Among Uranus's companions, Miranda stands out immediately. This small moon carries some of the most dramatic terrain found anywhere in the solar system. Towering cliffs rise several kilometers straight up, forming walls of ice and rock that drop sharply into canyons below. The surface appears stitched together from mismatched pieces, with patchwork regions that look like fragments from different worlds. Some areas are smooth and gently rolling, while others are carved by deep valleys, ridges, or jumbled blocks that seem to have been rearranged by enormous forces. Miranda gives the impression of a world assembled from memories of older landscapes, its features rejoined in a way that hints at a violent past. The cliffs themselves are remarkable not only for their height, but for how abruptly they rise from the surrounding plains. Standing near the edge of one of these escarpments would reveal a view stretching down into shadows that barely catch the faint light from the distant sun. Some of these formations may have formed when the moon was shattered and reassembled long ago, leaving behind surfaces that do not quite align. The mismatched patterns, dramatic rises, and unusual insets add to Miranda's sense of untamed quiet. A world shaped by upheaval but now frozen in stillness. Beyond Miranda, the larger moons move with a gentler presence. Titania, the largest, carries broad plains broken by long canyons that cut across its icy crust. These cracks suggest that the moon once expanded as internal heat caused the surface to stretch and fracture. The colours are muted, with slight variations that reveal ancient resurfacing. Titania's landscape looks calm, but its fractures hint at a world that once pushed outward from within, reshaping itself slowly over time. Oberon drifts even farther from Uranus, showing a duskier surface tinged with darker material. It holds many impact craters, some with bright flaws formed by later activity. The moon has a quiet dignity to it, shaped by collisions and internal changes that played out over long ages. Some fractures cut across its surface like faded scars, reminders of forces that once shifted the moon's crust. Oberon feels like a world that has carried its history with steadiness, changing slowly yet preserving clear signs of everything it has endured. Ariel offers a brighter, more varied appearance. Its surface contains smooth plains, deep valleys, and long canyons where shadows gather in soft lines. Some regions look as though water once flowed beneath the surface, warming the crust enough to carve channels before freezing again. Ariel's canyons stretch for impressive distances, dividing the terrain into large blocks that reflect the moon's internal processes. The mixture of bright and darker patches suggests areas that froze at different stages in its past, giving Ariel a layered appearance that feels subtly refined. Umbriel, by contrast, is the darkest of Uranus's major moons. Much of its surface absorbs light, giving it a shadowed appearance even when fully illuminated. Its craters are deep, with rims that cast long lines across the terrain. A single bright feature stands out, a circular patch inside a crater that contrasts sharply with the surrounding darkness. This lone bright spot gives Umbriel a quiet mood, as though most of its surface remains hidden beneath a veil of ancient dust and debris. The moon's calm darkness speaks to a long history of impacts and the gradual build-up of material that has dulled its original brightness. Together, these moons form a system shaped by many influences. Their surfaces show signs of fractures, impacts, and shifts that suggest they may have been altered by past collisions or internal heating. Some may have broken apart and reassembled, while others expanded or contracted as their interiors cooled. The tilted orientation of Uranus adds another layer of complexity, guiding how sunlight reaches each world and shaping their seasons in long, unusual patterns. The result is a collection of moons that feel both serene and slightly askew, orbiting a planet that has long since tipped onto its side. The entire Uranian system carries a sense of calm detachment. The muted colours, subtle ring system, and quiet moons form an environment that feels distant even among the outer planets. Yet the variety of landscapes, Miranda's cliffs, Titania's canyons, Oberon's dark plains, Ariel's deep valleys, and Umbriel's shadowed surface, reveals a region shaped by dramatic events that left their marks in unexpected ways. Each moon speaks to a past filled with sudden impacts and slow reshaping, balanced now by long stretches of deep quiet. A little farther out, the quiet of the solar system deepens. The glow from the sun thins into a cool thread of light, and another distant giant begins to take shape. Neptune's realm waits in that far-off cold, carrying its own collection of moons shaped by winds and frost. Moving toward it feels like entering a new chapter of the outer reaches, where a single captured world, Triton, stands apart with a history very different from the moons that came before. Triton moves around Neptune in a way that immediately marks it as different. While most moons follow the direction of their planet's spin, Triton circles the opposite way, slipping through the shadows in a backwards path that hints at a complicated past. Something about its motion suggests it did not form beside Neptune at all, but arrived from elsewhere and was drawn in by the pull of a world far larger than itself. The surface beneath that unusual orbit appears calm at first glance, with pale tones and wide stretches of frozen nitrogen. Triton is one of the coldest places known, yet even in that deep chill, the landscape refuses to stay entirely still. Voyager's brief visit revealed long, dark streaks stretching across the surface, each one created by a geyser that had erupted from below. These geysers are not explosive in the familiar sense. Instead, they rise as quiet columns of gas and tiny ice particles, drifting gently upward through the thin air before falling back in a light snowfall. Triton's atmosphere is barely more than a whisper, made of delicate nitrogen gas that forms faint clouds curling above the plains. Even at its thickest, the air would not carry sound the way people expect, yet it still behaves like a soft veil over the icy ground. As the moon travels through its slow seasons, this atmosphere thickens and thins, freezing onto the surface in the most frigid spells, and lifting again when sunlight returns. Its shape and motion suggest a life long before Neptune. Triton is thought to have once been a dwarf planet, similar in scale to Pluto, drifting in the distant outer darkness. At some point, Neptune's gravity caught it, pulling it into an orbit that gradually settled into the backward path seen today. That capture likely reshaped Triton's entire world, stirring its interior and creating stresses that left patterns on the crust. This history gives Triton a quiet, solitary feel, as though it remembers the time before it belonged to any planet. Standing at its frozen surface in imagination alone, the environment feels still and spacious. The horizon curves gently beneath a dim sky, where Neptune hangs large and soft in pale blue hues. Light from the sun reaches this world as a muted glow, bright enough to reveal detail yet faint enough to remind you just how far this place lies from the inner solar system. Nothing here is hurried. Everything moves slowly, from the drifting particles in the geysers to the slow turning of the moon itself. The backward orbit adds to this sense of detachment. Triton does not follow the rhythms shared by most moons. Instead, it glides in opposition, carving a path against the normal flow of the system. This motion changes the way tides act on the moon, and influences the way its interior shifts over time. Each cycle around Neptune is a reminder that Triton's story is unlike that of any other major moon. Even the colours contribute to its unusual character. Soft pinkish tones coat some regions where nitrogen ice mixes with traces of other compounds. Other areas appear smoother and newer, as though the surface has been renewed by slow, quiet processes beneath the crust. The result is a landscape that feels both ancient and freshly shaped, a world caught between stillness and subtle change. Triton's geysers offer one of the most striking features in this distant domain. They rise because sunlight warms dark patches on the surface, causing the material below to turn to gas. That gas builds up until it escapes in narrow jets, lifting particles high above the ice. These plumes can reach impressive heights even in such cold conditions, carried gently by the thin atmosphere before settling back down in wide patterns. There is no roar, no rush of sound. Every eruption is silent, leaving only the trace of its passage across the frozen plains. Despite its remoteness, Triton has shaped imagination on Earth since the first clear images arrived. It is a world that feels both haunting and calm, a reminder that even in the farthest places landscapes are active, shifting, and full of quiet detail. Its captured past, strange orbit, and silent eruptions make it stand apart from any of Neptune's other moons, and Neptune does not host Triton alone. Beyond this large, mysterious moon lies a scattered collection of smaller companions, far fainter and more irregular in shape. As attention moves toward them, the scale of this distant system becomes clearer, revealing how many little worlds circle in the cold blue shadow of a giant planet. Neptune's smaller moons move with a kind of quiet persistence, circling their distant planet without the dramatic flare of Triton. Proteus is the largest of these understated companions, yet even it carries a subdued presence. It is dark, uneven, and shaped more by chance than by any orderly process. Proteus resembles a frozen fragment left over from the solar system's earliest days, a world that never smoothed itself into a sphere and never quite grew large enough to reshape its own surface. Instead, it bears the marks of impacts that pressed shallow craters and ridges into its sides, each imprint a reminder of slow encounters in the cold space around Neptune. The surface of Proteus absorbs nearly all the light that reaches it, giving the moon a muted appearance. Under the faint Neptunian glow, its edges look softened, as though the moon were carved from dark charcoal. The landscape shows signs of ancient collisions, but nothing violent enough to break the moon apart. Instead, the impacts nudged its form into an irregular shape. From a distance, it appears almost like a drifting boulder, moving through a realm where sunlight is weak and shadows blend seamlessly into the surrounding black. Around Proteus, a cluster of even smaller moons follows their own steady paths. Names like Larissa, Galatea, Despina, and Thalassa belong to worlds that are easy to overlook because of their size and dimness. Each of them circles close to Neptune, often just beyond the delicate arcs of the planet's rings. Their orbits sit within a region influenced by Neptune's gravity in ways that nudge and guide them, but unlike Triton, these moons, formed alongside the planet itself, they are pieces of the original system, shaped slowly across immense spans of time. Larissa is slightly larger than the smallest moons, but still tiny in comparison to Proteus. Its surface is pitted and uneven, with shallow craters scattered across it like dimples pressed into soft clay. The moon's rotation keeps its features drifting calmly through the thin sunlight, revealing a landscape that has changed very little over billions of years. It moves so close to Neptune that it almost seems to skim along the outer edge of the planet's faint rings, tracing a path that feels narrow and precise. Galatea and Despina play a different role within this quiet system. These two moons help guide the structure of part of Neptune's rings, exerting small tugging forces as they pass through their orbits. Their gravity influences the thin arcs of particles drifting around the planet, gently keeping them in place. The moons are not shepherds in the dramatic sense seen around Saturn's rings, but their presence is enough to keep Neptune's ring features from spreading or dispersing too quickly. Each moon moves with the confidence of an object whose orbit has held steady for an extremely long time. Farther outward, Thalassa follows a path that feels almost relaxed. It drifts between other moons without strong interactions, keeping its distance as though content simply to move quietly within its own lane. Its shape is irregular, shaped by impacts that left it looking somewhat flattened on one side. The Moon's surface is dark, like most of Neptune's smaller companions, absorbing the faint sunlight rather than reflecting it. Still farther from Neptune lies Nereid, a moon known for its unusually stretched orbit. Rather than moving in a neat circle, Nereid travels on a path that carries it far from the planet and then brings it close again over the course of a long cycle. This eccentric orbit gives Nereid a wandering feel, almost as though it cannot decide how fully it belongs to Neptune. Because of this journey, the Moon experiences large changes in the strength of Neptune's pull, giving it a restless, roaming quality compared to the inner moons that stay close and steady. Nereid's surface remains largely unseen in detail, but scientists believe it too is dark and irregular, shaped by the same slow collisions that influenced its neighbours. Its distant orbit places it on the border between Neptune's realm and the outer fringes of the solar system, where space begins to blend into the scattered world of icy debris beyond. The most remote of Neptune's known moons is Ganymede, a small, dim world thought to be a fragment from an ancient collision. It may once have been part of a larger moon, possibly related to Nereid before some long ago impact shattered the original body into separate pieces. Ganymede now drifts quietly, holding on to whatever remains of that distant history. It circles Neptune at a great distance, where the planet appears small and muted in the dark sky. All of these moons share a kind of gentle isolation. They move through an environment where sunlight has softened into a faint wash of pale blue, and where temperatures stay extremely low. There is little here to disturb them. Their orbits continue with minimal disruption, and their surfaces remain unchanged except for the rare impact that leaves a new mark. Each moon seems to float with unhurried patience, keeping company with Neptune while also feeling far removed from the busier worlds closer to the Sun. These small Neptunian moons help complete the portrait of a system that stretches outward in layers, from the large and unusual Triton to the clusters of quiet, shadowed companions. Together they form a kind of soft boundary marking the edge of the planet's domain. Beyond them lies a region where even these faint worlds begin to fade into the vastness of the outer solar system. As the path continues outward, the environment shifts again. Neptune's dark moons give way to an even more distant territory, filled with icy bodies, slow orbits, and ancient material. Moving into this space feels like stepping toward a frontier where dwarfed planets and frozen fragments carry the oldest stories of the solar system. Pluto sits deep in the Kuiper belt, far beyond the bright activity of the inner planets, and yet it holds one of the most graceful arrangements in the entire solar system. It shares its space with Charon, a companion so large in relation to Pluto that the two behave less like a planet and its moon, and more like a true double world. They rotate together, locked in a perfect balance, always keeping the same faces toward one another. No matter how much time passes, the same hemisphere of Pluto always looks toward Charon, and the same hemisphere of Charon always faces Pluto in return. It creates a sense of stillness between them, as though both worlds are engaged in a quiet, endless conversation. What makes their bond even more remarkable is the point around which they orbit. Instead of Pluto pulling Charon around itself, the two orbit a shared centre of mass that lies in the empty space between them. That point hovers above the surface of Pluto, suspended like an invisible anchor holding the pair in their mutual rhythm. The effect is gentle but unmistakable, giving the pair a motion unlike anything seen in the inner planets. They swing around their shared balance point every few days, moving with a steadiness shaped by their mass, their distance, and the history that tied them together long ago. Pluto itself shows a surface full of variety and subtle colour. Light regions made of nitrogen ice sit alongside darker patches, rich in organic molecules, shaped by slow processes at extremely low temperatures. The famous heart-shaped plain spreads across one hemisphere, its smooth surface contrasting with nearby rugged terrain. Across the planet, deep troughs and tall ridges rise where the crust has cracked or lifted over time. These features speak to a world that's not completely frozen in its behaviour, but one that still responds to the slow shift of its ices, the faint pull of sunlight, and the tides created by Charon's presence. Charon in turn carries its own personality. Its surface is quieter and more muted than Pluto's, marked by large canyons and regions where frozen material has settled unevenly. A reddish cap at its northern pole adds a splash of colour, thought to be created by material escaping from Pluto's atmosphere and settling on Charon's surface. Together, these worlds create a pair that feels balanced not just in motion but in appearance, with each body showing signs of a long and shared history. Orbiting this double world are 4 much smaller moons, each tiny compared to Pluto and Charon. Their names, Styx, Nix, Kerberos, and Hydra, carry a certain mythic tone, fitting for their distant icy home. These moons do not orbit in perfect circles, nor do they spin in stable, predictable ways. Instead, they rotate chaotically, as though the gravitational interplay between Pluto and Charon leaves them in a state that never fully settles. Their shapes are irregular, more like frozen fragments than spherical worlds, and their surfaces are bright from the reflective ice that coats them. Styx is the smallest of the group, barely more than a drifting block of ice, yet it holds its place within the system with surprising stability. It moves between the orbits of Charon and Nix, following a path shaped by the gravitational pull of both larger bodies. Its movement is quiet, but its presence helps anchor the structure of the outer orbits. Nix, larger and more reflective, shows a surface mottled with light patches created by icy deposits. Its rotation is especially unpredictable, tumbling rather than spinning in a steady way. As Nix follows its elongated path around the double world, its orientation shifts constantly, giving it a restless quality that contrasts with the calm balance of Pluto and Charon. Kerberos is darker, with a surface that appears to contain significant dust mixed with ice. Its shape is elongated, almost resembling 2 smaller bodies that gently merged. Despite being dimmer than the other small moons, Kerberos keeps a steady orbit between Nix and Hydra. The faint light it reflects blends easily into the blackness around it. Hydra, the outermost of the 4, is the largest and brightest of the smaller moons. Its reflective surface shows patches of frozen material that glint softly even under the distant sunlight. Hydra's shape is irregular, but its orbit is surprisingly stable. As it circles the double world, it helps define the quiet edge of the Pluto-Charon system, marking the boundary where their gravitational influence begins to loosen. Together, these 6 bodies, 2 locked in perfect synchrony and 4 drifting around them, form a system that feels more like a dance than a simple arrangement of moons. The balance between Pluto and Charon sets the rhythm, and the smaller moons follow along, each with its own role. The result is a kind of celestial harmony that remains hidden from the inner solar system, unfolding in a region where light is scarce and the pace of change is slow. There is something especially gentle about the Pluto-Charon partnership. The way they face one another, always presenting the same sides, creates a sense of calm rarely seen elsewhere. Even their orbit around the Sun is leisurely, taking more than 200 years to complete a single journey. The double world drifts through the Kuiper belt with an air of patience, moving among countless icy bodies that share its cold environment. This region beyond Neptune holds an entire population of distant objects, each shaped by ice, faint sunlight, and long passages of time. As the focus begins to shift outward from Pluto and Charon, the wider Kuiper belt comes into view. It stretches across a vast region filled with dwarf planets, scattered fragments, and frozen remnants from the early days of the solar system. These far-off companions wait quietly in the deep cold, each one carrying its own story etched into ancient ice. At the far edge of the solar system, where sunlight arrives as a pale wash rather than a warming glow, an entire population of distant worlds moves in slow, deliberate paths. This region, known as the Kuiper belt, stretches out like a frozen frontier. Within it drift dwarf planets shaped by ancient collisions, gravitational nudges, and the quiet work of ice under unimaginable cold. Some of these worlds travel with companions of their own, forming small families that circle each other in peaceful isolation. Eris is among the most striking of these distant bodies. Larger than Pluto and covered in reflective ice, it moves on an orbit that carries it extremely far from the Sun before looping back inward over hundreds of years. Its world is so cold that its surface ices harden into a frost that barely changes over time. Eris does not travel alone. It has a moon named Dysnomia moving steadily around it. The presence of this moon helps reveal Eris's mass and density, offering clues about its interior. Together they drift across an orbit that is both elongated and tilted, marking Eris as one of the most remote dwarfs, with a companion anchored firmly in place. Haumea stands out in a completely different way. Instead of being nearly spherical, Haumea is stretched into an elongated shape, spun into a rapid rotation that gives it the appearance of a smooth, icy ellipsoid. This unusual form likely came from a powerful collision long ago that fractured its crust and scattered pieces outward into space. Some of those fragments eventually formed moons, now known as Hyaka and Namaka. These moons follow orbits shaped not only by Haumea's gravity, but also by its odd shape, creating a system unlike anything in the inner solar system. The entire group feels like the aftermath of an ancient impact, preserved in slow motion at the distant edge of the Sun's reach. Makemake brings yet another personality. This reddish world reflects sunlight in a muted glow, its colour shaped by frozen methane that has been slowly altered by countless years of exposure to cosmic radiation. For a long time, Makemake seemed solitary, drifting without any known companions. Then a tiny moon, discovered much later, was seen circling it like a quiet partner, barely noticeable against the glare. The presence of this moon transformed Makemake from a lone wanderer into a system, small but complete, moving together through the deep cold. Beyond the best-known dwarf planets lies a scattered network of others, some smaller, some stranger, all shaped by ice and distance. Orcus circles the Sun in a path that mirrors Pluto's in many ways, but is shifted to the opposite side of the solar system. Its moon, Vanth, is large enough to give the pair a resemblance to the Pluto-Charon relationship, though their behaviour and balance differ. The pair moves in a slow orbit that plays out over centuries, their path set by gravity that acts softly at this range. Quaoar, another dim and distant dwarf planet, also has its own moon, named Weywot. The orbit of Weywot has an unusual tilt compared to Quaoar's equator, hinting at past disruptions or impacts. The system carries a sense of quiet imbalance, as though something in its past nudged it slightly off-center. Even so, both bodies continue along their enormous orbit around the Sun, unhurried and undisturbed. These systems together form a kind of archipelago in the outer darkness. Each dwarf planet is like an island, separated by vast distances yet shaped by similar forces. Their surfaces are covered in frozen materials, nitrogen, methane, or water ice, solidified into crusts that shift only slowly over time. Unlike the inner planets where heat drives weather and volcanic change, these distant worlds are influenced mainly by the faint pressure of sunlight and the gentle tug of nearby moons. The moons themselves are usually small, irregular and icy, glinting faintly when sunlight reaches them. They orbit in silence, their paths determined by the shape and mass of the dwarf planets beneath them. Some follow near-perfect circles, while others move in elongated loops shaped by past interactions. Their motions unfold so slowly that generations can pass without any noticeable shift to the human eye. Yet over millions of years their stories continue to evolve. Imagining this region feels like picturing a quiet chain of frozen outposts. Each tiny moon and dwarf planet drifts in a realm where darkness is the default state and the sun looks like a bright star rather than a disk. The emptiness between them is vast but not empty of meaning. These worlds carry the building blocks left over from the solar system's earliest days, preserving them like time capsules. Their slow movement, their icy surfaces and their companion moons all tell a story of formation, scattering, and survival. Some of these moons may even have been captured rather than formed in place. The distances are so great and the speed so slow that a wandering fragment drifting past a dwarf planet could lose just enough momentum to be pulled into orbit. Over time, that captured object would settle into the system, becoming part of the dwarf planet's small family. Others may have been created by collisions, with fragments coalescing into new moons that orbit the parent world in steady paths. The Kuiper belt in this sense is not just a frontier but a neighbourhood of ancient relationships. Its moons may be small, but they reveal the histories of the worlds they orbit, the impacts that shape them, the tilts that define them, and the fragments left behind from a time before planets fully formed. Drifting through this region offers a glimpse into the earliest architecture of the solar system, preserved in ice rather than rock. Moving forward from this calm collection of dwarf planets and their companions brings a change in the types of objects that appear. The next part of the journey looks toward captured bodies, wandering fragments, and moons that arrive through chance rather than formation. Objects that do not belong to any single world, but were drawn in by gravity's soft but persistent pull. There are moments in the history of the solar system when an object that has spent millions of years drifting alone suddenly finds itself caught in the gravity of a much larger world. It is not a simple grab or a sudden snatching of motion. It is a slow exchange, as though two bodies are learning the rhythm of each other's path. Under the right conditions, a wandering fragment can fall into step with a planet and begin circling it in a long looping orbit. This process, known as gravitational capture, turns lonely travellers into moons. Capture works only when movement and timing line up in a very particular way. A passing object must approach closely enough to feel the pull of a planet, but not so quickly that it races past again. Something must drain just enough of its momentum for the object to lose its freedom without falling straight into the planet itself. Sometimes this slowing comes from interactions with an existing moon. Sometimes it happens because an object brushes through the thin outer edge of a gas giant's atmosphere, and sometimes it occurs simply because of the subtle dance between multiple bodies moving together. However it unfolds, the result is the same. An outsider becomes a companion. One of the clearest examples of this is Triton, now the largest moon of Neptune. Triton moves in the opposite direction to Neptune's rotation, a detail that reveals its past. No moon born from a planet's own formation would orbit backwards. Such a path makes sense only if Triton arrived later, captured after forming elsewhere. Long ago, it was likely part of a group of icy bodies similar to Pluto and Eris, travelling along a wide orbit in the outer solar system. At some point its path crossed Neptune's, and gravity drew Triton inward. Over time its orbit settled into the shape we see today, turning Triton into the dominant moon of Neptune even though it began life as a wanderer. Jupiter offers an even broader display of captured objects. Scattered around the giant planet are dozens of small irregular moons that show every sign of arriving from elsewhere. They move in tilted, uneven paths. Many orbit in the opposite direction to the planet's spin. Their shapes are lumpy and rough, their surfaces scarred by impacts. These are fragments that began their existence as asteroids or icy bodies travelling the Sun's path independently. Yet once they wandered too close to Jupiter's immense gravity, their freedom came to an end. Instead of continuing across the solar system, they found themselves turning again and again around the giant world, settling into distant looping orbits. Capture can even happen in stages, with an object arriving in a chaotic path that gradually becomes more stable. At first, the orbit may be extremely elongated, sending the new moon far from the planet before drawing it close again. Over long spans of time, gravitational interactions smooth the motion, reducing the extremes. The captured moon begins to circle more steadily, as though the planet is slowly teaching the newcomer the correct pace and direction. There is a quiet poetry in imagining these events, a lone fragment of rock or ice, drifting through the dark for ages, eventually crosses paths with a world large enough to alter its destiny. Instead of moving endlessly through open space, it becomes part of a system, tied into cycles that stretch across centuries. It orbits, it settles, it finds a place. The story feels almost gentle, even though the physics behind it is strict and unforgiving. Some captured objects come in groups. Collisions between fragments near a giant planet can break apart a larger body, leaving multiple smaller pieces that all fall into orbit around the same world. This is one way families of irregular moons form. Each piece follows its own path, yet all share a common origin rooted in the chance encounter that led them to the planet in the first place. Over the ages, these moons drift in formation, circling together in a way that hints at the event that first brought them there. Capture plays a quiet but important role in shaping the solar system's population of moons. It explains why some orbits are tilted or backwards. It accounts for moons that look nothing like the worlds they circle. It reveals how the outer solar system collected strange companions from the leftover debris of planetary formation, and it adds another layer of variety to the ways moons can be born. Not all moons form through capture, of course. Some emerge from debris created by massive impacts. Others grow within the material left over from a planet's formation. Still others form in pairs or families, growing together from the same cloud of dust and gas. The different methods of moon formation create the incredible diversity seen across the solar system: volcanic moons, icy moons, fractured moons, smooth moons, and moons with hidden oceans beneath their crusts. With captured moons now explored, the next step is to look more closely at how moons emerge in the first place. Each type of formation leaves telltale marks in the shapes, motions, and textures of the moons we observe. Moving from the stories of wandering objects toward the origins of moons themselves brings the journey into a new chapter, one that turns from the paths moons take to the ways they begin. Moons begin in many different ways, shaped by conditions that vary from planet to planet and era to era. Some arise calmly from swirling disks of early material. Others are born in violence, the aftermath of enormous collisions that scatter fragments into space. And a few arrive from far beyond, drifting close enough to be caught and held by a planet's gravity. Each path creates a different kind of companion, and understanding these origins helps explain why the solar system's moons are so varied in appearance, behavior, and history. Around the giant planets, moon formation often starts with a broad disk of dust, ice, and gas left over after the planet itself takes shape. These disks behave like miniature versions of the one that surrounded the young sun. Material inside them slowly gathers into clumps, and those clumps grow through countless tiny collisions. Over many millions of years, repeated merging builds small bodies that eventually become moons. Their orbits reflect the structure of the original disk, circling in the same direction and along paths that lie in the same broad plane. This orderly arrangement is why moons around Jupiter and Saturn often appear so well organized, following smooth patterns like beads placed on circular threads. Within those early disks, growth is incredibly slow. Grains of dust collide so gently that they stick together instead of bouncing apart. Ice crystals merge and create slightly larger pieces. These pieces attract more material by their growing pull. Over time, a few bodies become dominant, sweeping up surrounding debris to reach the sizes we recognize today. Every moon that forms this way carries the signature of that steady, patient process. Their rounded shapes, stable orbits, and shared motion around their planets all point to long ages of calm construction. Not all moons grow inside these gentle disks. Some come from dramatic collisions, moments when two large bodies collide with such force that parts of them are thrown into orbit as fine debris. At first, that debris forms a ring of broken rock and dust spread around the world. Over extended periods of time, the fragments within this ring collide at low speeds and begin to clump together. They drift, merge, and collect more material as they grow. The process resembles watching shattered pieces of a sculpture slowly rebuild themselves into a new form, though the timescale stretches across millions of years. Moons formed this way often carry the chemical fingerprints of the worlds that created them. Their composition mirrors the material from the collision, giving clues to what those earlier bodies were like before they struck each other. Earth's moon is one example of such a birth. Long ago, a massive impact scattered molten debris around the young Earth. That debris eventually coalesced into the moon, leaving behind a companion tied to the planet through a history written in heat and violence. Other worlds may have experienced similar events, though their debris either escaped entirely or never gathered into a single stable moon. Where conditions are right, however, a once shattered disk can become a family of moons instead of just one, revealing how collisions do not always lead to destruction, but can set the stage for new beginnings. Some moons, as explored earlier, are captured rather than formed in place. These objects drifted for ages before encountering a planet large enough to alter their fate. The capture process requires delicate timing, with the traveller arriving slowly enough for the planet's gravity to take hold. Once caught, the object settles into an orbit that may look nothing like those of moons formed within disks. Tilted paths, elongated loops, and backwards motion all signal a past spent outside the system it now calls home. These captured moons add a note of unpredictability to the populations around giant planets, making each system feel like a blend of locally grown worlds and distant visitors. Regardless of how they begin, moon formation unfolds across immense spans of time. Nothing about the process is quick. Dust must collide thousands upon thousands of times to grow into even a small pebble. Fragments left from a collision drift for centuries before gathering into shapes large enough to attract more material. Captured moons adjust their orbits over millions of years before settling into steady paths. The slow pace gives each moon a layered history, with long intervals where nothing dramatic happens and brief, transformative events when everything changes at once. These varied origins explain why the solar system contains so many different types of moons. Some are smooth and rounded, shaped by their own gravity. Others are jagged and uneven, too small to pull themselves into spheres. Some hide oceans beneath their crusts, warmed by internal processes tied to how they formed. Some are volcanic. Some are quiet. Some carry the scars of ancient collisions that still show, untouched for billions of years. Together they form an enormous collection of worlds, each shaped by its own beginning. As these stories come together, the focus naturally shifts toward what lies ahead. Moon systems are not fixed in place. Orbits evolve, surfaces change, and internal heat fades slowly over time. The future of moons stretches just as far as their pasts, promising new patterns, new arrangements, and new stories still unfolding in the centuries to come. The future of moons unfolds slowly, measured not in centuries but in spans so long they feel almost outside the reach of imagination. Even so, the changes are real, and they are happening right now. Earth's own moon is drifting away from the planet by a tiny amount each year. It is such a small shift that no one alive will ever feel it, yet over millions of years it adds up. As the moon moves outward, the length of each day on Earth grows a little longer. Long ago, a single day was noticeably shorter, and in the far future it will stretch slightly more. The moon and the Earth are locked together in a quiet exchange of energy, and this unhurried outward movement is part of that long conversation between the two bodies. This drifting also affects the tides that shape the coastlines. The moon's influence will slowly change as it moves farther away, softening the reach of high tides over very long spans of time. Even so, the moon will remain a powerful presence for many millions of years to come. The exchange between Earth and its moon is gentle, but it is steady, and it gives a glimpse into how moons everywhere continue to evolve. Tidal forces do far more than shape oceans. They alter orbits, rotations, and internal structures. When a moon circles a planet, their gravitational pull stretches each other ever so slightly. If a moon's orbit is not perfectly circular, this stretching can shift and relax repeatedly, warming the interior of the moon over immense periods. This process can keep surfaces active, can drive geological cycles, and can even fracture worlds. Over long enough timescales, tidal effects can slowly lock a moon so that it always shows the same face toward its planet. Many moons in the solar system have already settled into this state, and others are still drifting toward it. Some moons experience more dramatic futures. Triton, Neptune's largest moon, is slowly spiraling inward. It orbits Neptune in the opposite direction that Neptune rotates, and this unusual arrangement means that tidal interactions work in reverse. Instead of drifting outward, Triton's orbit shrinks. One day, an extremely long time from now, Triton may come so close that Neptune's gravity tears it apart. If that happens, the fragments could spread out into a ring, giving Neptune a bright, detailed band like Saturn's. The timescale is far beyond any human era, but imagining such a transformation adds a sense of motion to what otherwise feels like a frozen region of the solar system. Other moons will follow their own paths. Some may move outward and eventually become too distant to stay in orbit, drifting into independent journeys through space. Others may slowly merge with their planets. A few might settle into new rhythms as the planets themselves change over great stretches of time. The quiet forces guiding these movements never turn off. They continue through ages of ice, through shifting landscapes, through every rise and fall of future worlds. Thinking about these vast futures can feel almost like watching a slow dance play out in a room with dim lights. Nothing appears to change from one moment to the next, yet when enough time passes, the positions of everything have shifted. Moon systems evolve in this quiet way. They stretch, adjust, lock, relax, and reshape themselves gradually, following the laws that have guided the solar system since its earliest days. The moon above Earth will keep drifting away. Triton will continue inching toward Neptune. Countless smaller moons will keep their slow orbits, influenced by forces so gentle that they barely leave a trace from one era to another. These long processes become the architecture of the far future, carving paths that no one will ever witness directly. Yet the patterns continue, as steady as the passing of time itself. Even long after present civilizations fade into memory, the moons of the solar system will still be evolving. Their orbits will continue changing, and their surfaces will continue recording subtle shifts. The shapes of the moon system seen today will not remain exactly as they are. They will mature and drift, guided by many of the same forces that shaped them in their earliest moments. Eventually, the imagination begins to stretch out far enough to see the solar system not as a fixed arrangement, but as something alive in its own slow way. A place where worlds rearrange themselves over eons, moving into new positions, settling into new balances, and occasionally breaking apart or forming anew. The moons are part of this long story, each moving according to quiet rhythms that never stop. This long view of time sets the stage for one final gentle shift in perspective, drifting away from the mechanics of orbits and tides, and toward the place moons hold in the broader story of the solar system. The solar system's moons form a quiet collection of worlds that never rush, never struggle for attention, and never try to overshadow the planets they accompany. They simply exist, moving steadily along paths shaped by gravity and time. When viewed together, they feel less like separate objects, and more like members of a family spread across great distances. Each one carries its own history, its own personality, and its own slow rhythm. They glow softly in reflected sunlight, scattered across space like lanterns marking the edges of ancient paths. Some moons hold stories of fire and restlessness. Their surfaces shift, crack, and rebuild, driven by forces deep beneath them. They remind you that even far from any star, warmth can find a way to rise from within. These worlds echo with motion and change, yet from a distance they look calm, almost serene. Their energy is something you feel only when imagining what lies beneath their surfaces, where molten rock or heated oceans continue their long cycles unnoticed in the dark. Others are places where ice dominates every horizon. Their crusts glisten beneath distant sunlight, carved by fractures, ridges, and valleys that speak of stresses slowly bending them over ages. These moons carry vast memories within layers of frozen material. Each line and groove is a trace of something that once pushed or pulled, froze or shifted. These icy companions feel ancient, as though they have been watching the planets move for longer than anyone could count. There are moons that follow paths unlike any others. Some were captured, arriving from elsewhere before being drawn into new orbits. Their journeys hint at wandering beginnings. They drifted through the early solar system, passing close enough to a giant planet for its gravity to gently claim them. Now they move in loops that reveal those unconventional origins. The stillness of their surfaces hides the long travel that brought them to where they now circle. A few moons look as though they were pieced together from older events. Their shapes, their ridges, and their mismatched terrains suggest stories of impacts that broke and rebuilt them. These moons hold reminders of the collisions that once shaped the early solar system, when fragments of rock and ice moved chaotically before settling into calmer patterns. Their scars feel like quiet records etched over unimaginable spans of time. Some appear almost newborn when compared to the oldest worlds. They were formed from pools of debris left after powerful impacts or slow accumulations of particles circling a planet. Over time, the small fragments drew together, merging and compacting until they became full moons. Their youth is not measured in years anyone could count at a glance, but their surfaces still carry the freshness of worlds that have not been softened by endless cycles of weather or internal heat. Across this wide family, the materials differ, the temperatures change, and the landscapes hold every possible form of stillness and motion. Yet they are united by the same fundamental experience. They orbit in the quiet shadows of planets, shaped by forces they never resist. Moons do not choose how they form or where they travel. Instead, they allow gravity to guide them, maintaining their slow arcs with remarkable patience. Each moon acts as a keeper of the history that shaped it. Their surfaces hold memories of times older than any human story. Some preserve ancient craters from collisions that shook their entire world. Others hide oceans beneath ice, where layers record subtle movements and heat from deep within. Some have faces turned forever toward their planets, watching them endlessly without ever seeing the far side of the sky above. All these patterns reveal the long, unbroken flow of time. Together they form one of the solar system's most peaceful collections. Their beauty is gentle rather than dramatic. Their stories are vast but unhurried. Passing from one moon to the next feels like drifting between rooms of a silent museum where each display waits patiently to be noticed. The volcanic moons glow with inner motion. The icy ones shimmer like sculptures carved from frozen light. The captured wanderers carry hints of distant beginnings, and the ancient fragments hold memories of the solar system's earliest turbulence. The diversity of these moons helps reveal how enormous and varied the solar system truly is. Each moon adds another shade of possibility. Some show what heat can do even in far places. Others reveal how ice can create landscapes as detailed as any mountain range on Earth. The smallest ones demonstrate how even tiny worlds can survive for billions of years without losing their place. The largest moons act like miniature planets, with their own internal layers and histories. All of them together create a moonlit family circling the sun in slow patterns. They are scattered across great distances but linked in the way they respond to the gentle tug of gravity, orbiting steadily through the dark. Imagining them as one group gives a sense of continuity, as though the entire solar system is connected by the rhythm of moons moving around their companion worlds. Thinking about them this way helps reveal a softer truth. Moons are not simply objects. They are reminders that even in the coldest parts of space, stories continue unfolding. These stories may be silent, but they are not empty. Every moon is proof that time shapes all things with patience. The silence of their orbits is not a lack of activity. It is a sign of the slow, steady processes that guide the evolution of entire worlds. As the imagination moves gently from one type of moon to another, the solar system begins to feel like a place that breathes. Not quickly, not loudly, but with the steady calm of an ancient landscape. There is rhythm in the orbits, memory in the ice, and movement hidden beneath surfaces that seem still at first glance. The moons are part of this quiet harmony, each contributing its own tone to the wider arrangement. This soft sweep across the moonlit family creates a sense of calm, as though the entire solar system has settled into a deep, slow exhale. The moons drift on, each following paths laid out long before any human eyes looked up to notice them. Allowing that thought to settle creates a gentle opening toward the stillness waiting in the conclusion, where the journey gradually eases into its final, peaceful rest. The solar system becomes a quieter place when you pause long enough to notice the small companions moving through it. Each moon follows its own path, shaped by ancient events that played out long before any familiar world had settled into its present form. Taken together, they form a collection that reveals how patient the universe can be, how willing it is to let things unfold over immense stretches of time. They remind you that nothing in space is ever truly still, yet everything moves with a calm that feels almost meditative when viewed from a distance. As you drift back through the memories of volcanic surfaces, frozen seas, battered crusts and delicate atmospheres, the variety becomes more soothing than overwhelming. Some moons glow with activity deep within their interiors. Others remain unchanged for longer than their entire eras of life on Earth. A few wander in odd directions, captured by gravity long after the early shaping of the planets. Each carries quiet history, and each shares it without urgency. There is no sense of competition in their motions, only a gentle coexistence that has lasted for billions of years. Moving through these places in your imagination feels like gliding from one story to another, each one adding a subtle detail to the wider picture of how worlds evolve. None of them rush you forward. They allow you to linger on the smooth curves of icy surfaces or the faint shimmer of dust suspended above a crater. Even the dramatic moons, the ones shaped by fire or breaking tides, settle into stillness once you step back far enough. Up close they may appear violent or chaotic, but from afar they are part of a wider harmony, woven into the pacing of the planets themselves. Thinking of them like this gives the solar system a softer mood. It becomes less a collection of worlds and more a family of places moving along together. Jupiter's moons travel in steady patterns. Saturn's drift among rings that look delicate from a distance. Uranus's companions move through seasons that last for decades, while Neptune's follow long, cold paths beneath a dim sun. Farther out, even the dwarf worlds keep company with their own small satellites, turning through a darkness that hardly changes at all. The whole system feels as if it breathes slowly, with each moon adding to that quiet rhythm. The scale of time involved can be hard to grasp, yet there is comfort in the idea that these changes are measured in ages rather than moments. Moons grow or shrink depending on the tides they raise. Their orbits shift so gradually that entire civilizations would rise and fall without noticing. Even the most dramatic outcomes, like a moon drifting outward forever, or spiraling inward toward a distant destruction, unfold with the softness that leaves no sudden shock. It is a reminder that the universe works with patience, relying on gentle shifts rather than abrupt turns. Letting your thoughts move across all these worlds brings a kind of timelessness. You can picture standing in the shadows of one moon, then imagining the faint glow reflected off another, knowing both scenes belong to the same grand environment. That sense of continuity creates a calm that runs deeper than the facts themselves. It shows how each moon, with its own shape and story, helps reveal the longer history of the solar system. They are like chapters in a book written out of rock and ice, with no need for words to explain what happened. Even the silence out there has texture. On some worlds, the quiet comes from a lack of air. On others, it comes from being so far from the sun that sound feels unnecessary. Yet despite that stillness, everything keeps moving with dignity. Orbits continue. Tides shift. Thin atmospheres rise and fall in barely noticeable waves. Nothing is frozen in time, but nothing is hurried either. It all unfolds in a way that invites you to slow down with it, to match its pace for a moment and breathe a little more gently. As your thoughts sweep across these moons one last time, the feeling they leave behind is not one of distance but reassurance. They remind you that small things can hold enormous histories. They show how resilience can take many forms, whether in volcanic renewal, icy stillness, or steady endurance under endless bombardment. They prove that beauty exists even in places where the sun barely reaches, carried in the shapes of landscapes carved over unimaginable stretches of time. Let that awareness settle. Let it ease the tension from the day and replace it with a broader sense of perspective. The universe is full of movement, but not all of it demands attention. Much of it simply continues, calm and steady, offering a quiet backdrop for your own thoughts. These moons will keep circling long after tonight, long after every sound in your room has faded into softness. And as you rest with that thought, allow the slow rhythm of their orbits to guide you towards stillness. The solar system will keep turning gently in the dark, and you can drift with it for as long as you need.